अरे वीओडी लिंक वाली शीट कहाँ थी?
आप किसी और अकाउंट से
Yes. Then we have all the series
हाँ सर
maybe our time
अच्छा सर सुमन मैम को लिंक आपका नहीं है
दीदी का किसी और सेशन का आज का लिंक आज उसका पूरे आज उसके पूरे दिन का नाम था बिकॉज मैंने ना सबके लिंक चलाया है
यस यस
और चलो आई विल चेक विद राधिका अबाउट दैट आप जस्ट इन केस अपने पार्टिसिपेट का वैसा हो तब हम डॉक्यूमेंट भेज देते हैं आप अपने पास बैकअप है तो शेयर ये तुम उससे किसी भी सेशन में डालो है ना हाँ हाँ तो वही लिंक इसमें भी काम करेगा और तो आज का एजेंडा के हिसाब से व्हाटएवर यू बी रेडी विद दैट अगर आपको कोई मुझे ये नंबर पर तो पूरे टाइम जब तक टाइम लगता है तो मैं आपका ही चैट में बैठने से क्या काम नहीं करना है वो करें अगर कोई उसको म्यूट करना है अनम्यूट करना है जो पहले तो बेसिक आपको मुझे नहीं पता ना कौन क्या है तो पहले अगर आपको पता है तो आप कर दो अगर आपको मुझे नहीं हो पा रहा
मैम एक बार मेरा लाइव चेक करना इसको मैं बंद कर सकता हूँ नहीं चल रहा ना बस चलना भी नीचे 10:30 बजे था
आपको 15 minutes prior you have to find on और काम मैंने
क्या कह रही है?
सारा काम मैंने उसकी बॉडी में बता दिया
वेरी गुड 1 2 3 4 5 6
हाँ मैं अभी कर रही हूँ अभी जस्ट आई जॉइंट है या yes yes so by 10:30 I will ask now also I will ask them to test the link so, just a minute can hold on no उनकी staff her staff would be joining office her office हाँ या हाँ हाँ नमस्कार रमेश जी वो लिंक को क्लिक करके आप टेस्ट कर दीजिए अभी सिर्फ ज्वाइन करके रख दीजिए इसमें नहीं कर सकते क्या दूसरे सिस्टम से अच्छा तो 10:30 तक करा देंगे फिर हाँ 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 हम्म हम्म अच्छा हाँ 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 अच्छा अच्छा मैंने अभी वो टॉकिंग पॉइंट्स भी भेज दिए मैडम का फोन आया था वो भी भेज दिए इसको जैसे हो जाता 10:30 मैंने भेज दिया हार्ड कॉपी भी भेज दिया हाँ ठीक है ओके ठीक है सवराजन को बोल दीजिए जैसे आते हैं ठीक है हेलो हार्दिक हाँ वो ज्वाइन करेंगे अभी उनकी एक मीटिंग है मिनिस्टर ऑफिस में ज्वाइन कर लिया है उन्होंने
हेलो मिनिस्ट्री ऑफ पावर
यस सर
हमारा ऑडियो वीडियो क्लियर है
यस सर ऑडियो एकदम क्लियर है
वीडियो
सर ऑडियो में थोड़ा सा लैग्स है
ऑडियो में लैग्स है
हाँ अब क्लियर है वो एकदम से जब आपने लास्ट सेंटेंस बोला था तो थोड़ा लैग आया था
नाउ इट इज क्लियर हाँ वीडियो
ओके
आप थोड़ा सा कैमरा एडजस्ट कर लीजिए सीट के अकॉर्डिंगली कैमरा थोड़ा सा टेढ़ा है सर
ठीक है आई
हम ये बैकड्रॉप में वो नहीं कर सकते क्या कुछ
अभी ठीक है
हाँ इट इज फाइन नाउ
नहीं वो सही नहीं लगता है
ठीक ऑल गुड सर
ओके
इसमें ना
Yeah.
वो जब
So
मैं
आप exit नहीं कर रहे मीटिंग से,
11
right?
से उसमें इसमें नहीं आना है फिर आपको। मैं चली जाऊंगी 11 से 11:30 बजे तक। नहीं उसमें कुछ चाहिए होगा तो सामने रखो यहाँ पे, और मैं इसमें करूँगी क्योंकि ऐसे ऐसे दिखने से ना वो दिख जाता है। मैं इशारा कर रही हूँ आपको।
All good, sir?
यस सर। और वो
तो ये मीटिंग ऐसे ही कंटिन्यू रहने देते हैं, आप बस कैमरा बंद कर दीजिए।
ओके
ओके, और जैसे ही रहेगा तो आई विल आस्क यू टू पुट द कैमरा ऑन।
ओके सर।
हार्दिक, इसमें ये आ सकता है जैसे हम बात करेंगे ना डॉक्टर स्वरूप, तब वो उनका टाइटल आ जाएगा, मेरा और उनका और मिनिस्टर का। हेलो हार्दिक।
हेलो, यस मैम।
हार्दिक, जब व्हेन वी आर टॉकिंग ना, सो दैट
हम्म।
नीचे आ जाएगा वैसे हर एक का एफिलिएशन नेम एंड दिस थिंग हो जाता है ना, मिनिस्टर का और डॉक्टर।
सॉरी मैम, राइट नाउ व्हेन यू आर
तो
टॉकिंग तो
हाँ
अभी जैसे आई एम टॉकिंग तो आपकी स्क्रीन के टॉप पे लिखा होगा IISF 13 वर्चुअल इज टॉकिंग।
हाँ हाँ,
am I correct?
मेरे इसमें, हाँ आपके इसमें आ रहा है ISF 13 वर्चुअल।
Yeah, so when you are talking so I get to see Dr. Sangeeta Kasture is talking. यही अटेंडीज को भी दिखेगा।
इसमें ये कर दो ना, इसमें चेंज कर सकते हैं एडिट, संगीता कस्तूरी डिपार्टमेंट ऑफ बायोटेक्नोलॉजी। फिर डॉक्टर स्वरूप का भी ऐसे ही, मिनिस्टर का भी।
डॉक्टर संगीता
While they are
कस्तूरे, डिपार्टमेंट ऑफ बायोटेक्नोलॉजी। मैम say something now.
डिपार्टमेंट ऑफ बायोटेक्नोलॉजी, साइंटिस्ट छोड़ दो, डिपार्टमेंट ऑफ बायोटेक्नोलॉजी।
Yeah, so you can say when you're speaking at your bottom end, this
हाँ
is displaying. Yeah.
या गवर्नमेंट ऑफ इंडिया,
Ma'am,
देन
just
डॉक्टर
just
स्वरूप
hold
का
on for a
से।
second. I'm getting a call from minister's office. Okay.
हम्म।
Hello.
हाँ मैम ये भी ठीक है, सही है मैम, सही है ना पोस्ट? हाँ वो सही है, सही पोस्ट कर हाँ वो तो मैम कह रही सही है पोस्ट है, वो रेनू मैम का बता देते हैं।
Hello, Minister Power. हेलो,
पीछे फाइलें आ रही है, फाइलें
हेलो, फाइलें आ रही हैं।
फाइलें क्या करनी है?
हेलो, सर मिनिस्टर पावर।
हेलो,
हेलो, हेलो,
hello.
आई सर।
You're saying something.
सर हमारा व्यू ठीक आ रहा है ना?
बिल्कुल परफेक्ट आ रहा है।
आवाज में कोई लैगिंग तो नहीं है सर?
हाँ, आवाज भी एकदम सही आ रही है सर।
कोई इको नहीं है ना सर?
नहीं, कोई लैग नहीं है, अभी तक एकदम सही है सर।
तो
ओके, ओके सर।
नमस्कार तृप्ता जी।
Normal.
Hello, Hardik.
Yes, ma'am.
Yeah, my voice. Actually, I'm just going to the institute. Within 10 minutes, I will reach there. And I will
Okay.
open the whole series with my induction. So that,
Ma'am, you're not audible. Hello.
hello.
Yes, ma'am.
Yeah, I will that within 10 minutes, I will reach my institute, my
Okay.
office,
Hmm.
and again log in through my computer.
So, ma'am, one thing I'll tell you, we'll be going live by 10:30. So we have to do all these checks before that.
10:30.
Yes.
Okay. It will take maybe 5 minutes more actually.
Okay, so you just reach to the institute and then give me a call. Okay, we'll do things. Okay.
Okay.
Yeah.
Okay. Meanwhile, meanwhile, this link is on, so I will hear everything from you.
हार्दिक
Yes.
अभी ठीक है
Uh,
अभी ना
yes, sir. Camera is fine and audio is also fine.
कैमरे का अलाइनमेंट भी ठीक है
Perfectly fine, sir.
ठीक है थैंक यू हम यहीं पे बैठेंगे फिर
Yes. आप कैमरा और माइक ऑफ कर दीजिए सर. Okay.
ओके थैंक
Yeah.
हार्दिक हार्दिक
Yes, Avinash sir.
इस पे कोई बैकग्राउंड सेट कर सकते हैं अपने वीडियो के पीछे
सर बैकग्राउंड सेट करना है तो आप वर्चुअली कर सकते हैं बट आई विल सजेस्ट यू नॉट टू
ओके
क्योंकि उससे थोड़ा वीडियो में लैग्स आते हैं. ओके.
ओके ठीक है
यस सर. जो वो एक ऑफिशियल लुक आ रहा है दैट इज वेरी गुड. ओके.
ठीक है
यस.
वो मेरा ये हार्दिक
यस सर.
my voice is audible because
Yes sir. Perfectly audible and your video is also perfectly visible.
okay
Okay.
अच्छा okay ठीक है actually are we are going to do some mock session also in the morning because transition or I have to ask Sangeeta ji directly.
No sir, there's no mock session actually. We
Okay.
have the event flow, right? How will be going?
Okay.
First of all,
Okay.
Sangeeta ma'am will be speaking, then Renu ma'am will be speaking, then Minister sir will be speaking, and then you will be giving the vote of thanks.
Okay, in the same sequence, so it means just after the minister I have to propose the vote of thanks.
Yes.
No,
But we have a time limit till 11:30. Okay, we have to get
Acha.
this all done till 11:30 because
Nee.
after that, yes.
Oh, I mean to say like who is going to tell the minister as well as Sangeeta ji and Renu Sarup ji to start speaking, or they will automatically one after. they are
So
going to know, or some moderator is going to.
I'll suggest that you get on a call with Dr. Sangeeta ma'am directly over your phone and you discuss it over there. Okay, sir.
Okay.
Because in I think 6 minutes we'll be going live, so I have to do other preps as well.
Okay.
Okay.
हाँ जो भी हम फोन पे बात कर लेंगे.
Yes, sir. And I request you to please put your mic and camera off till 10:30. And one more request to everybody. All of you can hear me, right?
Yeah. I can.
Yes,
I
yes, we
can.
I
can hear.
request everybody to put the mic and camera strictly off when not speaking. If you
Yes, yeah.
the attendee screen as well, so just put your camera on, but the mic should be off when you're not speaking.
Okay.
Okay, the mic should be on only when we have to speak, and when we are done speaking, we'll put the mic off. Am I clear?
Right, right. Yes.
Yeah. Thank you very much.
Hardik, am I audible?
Yes, Priyanka ma'am.
ठीक है, all set then?
All set, Priyanka.
Okay, thank you.
We are keeping
हार्दिक,
ourselves
आ रही है आवाज
mute
मेरी?
because it will go on now live. Yeah.
नहीं, एक मिनट में अपना वो करता हूँ जरा, अपना एक बार बोलती हूँ ना. हाँ हार्दिक, आवाज आ रही मेरी? हेलो हार्दिक.
Yes sir, बिल्कुल आ रही है आवाज.
हाँ अभी ठीक है. आपका
एकदम
वीडियो,
क्लियर है.
आपका वीडियो?
मेरा वीडियो सर ऑन नहीं रहेगा,
अच्छा
बट मुझे आपका वीडियो दिख रहा है. ओके.
अच्छा ठीक है.
Rajan, yes, Rajan.
मैं ऑडियो और वीडियो दोनों ही म्यूट कर रहा हूँ, ठीक है?
हाँ
यस
ठीक है,
सर,
ठीक
फॉर
है.
राइट नाउ आप कर दीजिए, बट
Right.
6:30 ही आप ऑन कर दीजिएगा.
जैसे मंत्री जी आएंगे उसके बाद ही हम ऑन करेंगे इसको, तो हम
ठीक है
मैं
सर, तो जब मिनिस्टर सर आए तब आप ऑन कर दीजिए.
ठीक है,
हाँ
ठीक
हाँ,
है.
ठीक.
ओके ओके सर.
थैंक यू.
नीचे करो उसको, नीचे करो, नीचे नीचे नीचे. हाँ, बस थोड़ा सा, थोड़ा सा zoom, हाँ कम कर दो zoom. थोड़ा सा और कम कर. अच्छा ऊपर का थोड़ा सा ऊपर. नीचे नीचे. हाँ और थोड़ा सा. हाँ और ऊपर ऊपर ऊपर. नहीं ऊपर जो जा रहा है ना, जयपुर देगी वाला जा रहा है ना, इसको ऊपर थोड़ा सा और ऊपर करो, और ऊपर जाना है. ऊपर से अमित कैमरा ऊपर जाए. जूम जो ऊपर नीचे करते हैं, जूम नहीं करने के लिए बोल रहा हूँ, ऊपर नीचे करने के लिए बोल रहा हूँ. जूम बढ़ाओ अभी. हाँ जूम बढ़ाओ.
राजन म्यूट रखना.
हाँ जी मैम.
म्यूट रखो, ठीक है. हाँ, माइक म्यूट रखना प्लीज.
हार्दिक,
Yes, ma'am.
हार्दिक, ये बताओ, जब ये शुरू होगा, are we supposed to keep our video on or close?
Ma'am, it completely depends upon you whether you want to be a part of the screen or not
अच्छा,
in this
ठीक है,
inaugural ceremony. If you want to
ठीक
be a part of, you're most welcome to put your camera on, or otherwise put it off.
ठीक है.
But your mic should be off until and unless you are
Yeah,
speaking.
yeah, that.
Okay.
ठीक है.
Yes, ma'am.
Okay,
Okay.
Hardik. Oh, thank you.
अगर तुम्हारा बेसिकली दोनों सेम है ना, विथ मुझे दिखाने की जरूरत नहीं है, यू आर मोलेक्युलर।
मॉर्निंग एवरीबॉडी। बाकी चैनल सॉल्व कर दीजिए।
गुड मॉर्निंग सर।
Good morning, sir.
नमस्कार।
गुड मॉर्निंग।
नमस्कार। गुड मॉर्निंग।
Good morning.
Good morning. We can begin?
Sure.
संगीता जी।
Very good morning to all of you. Honorable Minister Shri R.K. Singh, Minister for Power, New and Renewable Energy and Minister for Skill Development and Entrepreneurship. Dr. Renu Surup, she is attending another meeting. She'll be joining in 1 minute. Department of Biotechnology, Ministry of Science and Technology, Government of India. Scientists, innovators, representatives from industries, entrepreneurs, students, and all participants from India and those who have joined from abroad. It is an honor and great pleasure for me to welcome you all to this inaugural session of Energy Conclave of 6th India International Science Festival. This mega event is jointly organized by Ministry of Science and Technology, Ministry of Earth Sciences, Ministry of Health and Family Welfare, and Vigyan Bharati. Honorable Minister and Madam Secretary, Ma'am, thank you so much for taking out time from your busy schedule and gracing this occasion with your kind presence. The energy security and environment both are important aspects for sustainable development of any developing country, and it's very relevant to India. Yesterday, during inaugural address, Honorable Prime Minister Shri Modi ji has emphasized on building the scientific temperament and collaboration to address the global challenges, especially in energy, environment, and health sector. Department of Biotechnology has been supporting innovations and R&D in biofuel area, which has a tremendous potential in India, which can significantly contribute to decarbonization of the transport sector, contributing to bio-based economy and generating employment in rural India. The potential R&D leads have been demonstrated successfully. However, there are a few challenges which are associated and mostly about supply chain biomass sustainability and to make them cost effective. Many researchers are taking efforts to address these challenges, and also there is a need for collaborative research through which the knowledge can be shared and also best practices can be shared from India as well as abroad. India is also a member of Mission Innovation, launched during COP21, a multilateral program of 25 countries, aimed to make collaborative efforts to accelerate innovation in clean energy transition. Department of Biotechnology and Department of Science and Technology are working closely with national and international stakeholders, including the Ministry of Power, Ministry of MNRE, and many other ministries. An international clean energy incubator has been set up by department in collaboration with Tata Trust, which has been providing suitable ecosystem to many young and innovators and startups by providing hand-holding through the entire product development cycle. During last 2 years, about 25 innovative clean energy solutions have been developed by these incubators. The India International Science Festival is an excellent platform for exchange of ideas, gaining knowledge and building partnerships. During next 2 days, several events have been organized under this energy conclave. Immediately after this inauguration, the technical webinar has been scheduled where the technical talks have been organized. 10 speakers will give about the technology, showcasing the technologies in various areas of clean energies. Tomorrow we have plenary talk which will be delivered by Dr. Fatih Birol, the Executive Director of International Energy Agency. He has kindly agreed to deliver the talk. Then we have a high-level roundtable where senior government officials and senior industry leaders, they are going to deliberate on various aspects of energy, which include energy access, efficiency, affordability, and for sustainable development and self-reliant India. For students, interesting quiz and slogan competitions will be organized tomorrow. And to create awareness about the embodied energy and carbon footprint, a workshop is also being organized at Delhi. An interview with Solar Man, Dr. Chetan Solanki will embark on 2 lakh kilometer energy Swaraj Yatra of 50 countries, including entire India, from November 26. So he will also be interviewed, so that these are the interesting events which will be delivered for today and tomorrow. On behalf of coordinators, my fellows, Dr. Vineet Saini, DST, Dr. Avinash from CSR NISTAT, Dr. Tripta Thakur, and Dr. Priyanka Vibha. Once again, I welcome you all to the this inaugural session and other events scheduled in next 2 days of Science Festival. With this brief background, I would now request Dr. Renu Swarup, Secretary, Department of Biotechnology, to kindly deliver opening remarks and share her perspectives. Ma'am, floor is yours. Thank you so much, ma'am, and please.
Thank you very much, Dr. Sangeeta. Very good morning to everybody. Honorable Minister Shri R.K. Singh ji. First of all, sir, thank you very much for your presence here. I would also like to take this opportunity to thank you for all the support that you and your ministry have given to the science and technology and other ministry agencies for taking forward this clean energy agenda for R&D and innovation. All the distinguished speakers in this India International Science Festival Energy Conclave, students, delegates, it's indeed a great pleasure to be here today and be part of this energy conclave. As Dr. Sangeeta Kasture has outlined, the importance of the India International Science Festival, the key programs that will be in the next 2 days, the various sessions, I think it has clearly given us an indication what really is the purpose of this energy conclave in the larger India International Science Festival that is being done for 4 days now. The theme for the India International Science Festival this time is Self-Reliant India and looking at technologies for global welfare. This energy conclave is also really looking at the same, that is renewable energy for self-reliant India and global welfare. The India International Science Festival, which is, in fact, this is 6th of the series, is a unique festival. And the word festival clearly tells us the uniqueness of it. We collect together to celebrate the achievements of science and technology, to celebrate the various experts, the mentors, the role models, and their achievements, to ignite curiosity and excitement amongst the young students, and build a very strong workforce for us as we move into our ambitious targets of each of the areas. The Honorable Prime Minister inaugurated this India International Science Festival yesterday, and in his inauguration speech, he clearly gave a very strong message to the scientific community. The clear message that the Honorable Prime Minister gave us is that it has to be scientific solutions which are going to drive the various targets and the ambitions of the nation. India responding to not just the Indian challenge, but for the globe. And the most important message he said is, if we have to fulfill our targets and ambition, human resource and capacity building is key and critical. And I think this India International Science Festival lays a lot of emphasis on that. Honorable Minister, sir, as you are aware, under the directions of the Honorable Prime Minister, your ministry, your vision, your target, and your leadership has set an ambitious target for the country of renewable energy. But as the key policies and the key enablers which have been put out to facilitate this, I think we are already on the right path. We've already made progress hugely in meeting a lot of those targets. And the science and technology, R&D and innovation play a very key and central role to achieving those targets. I think the convergence of R&D, innovation, new technologies with the various agencies and the various action plans that we have for technology deployment is what is most important and critical in this. We have been able to build a very continuous cycle from technology development to technology deployment. And I think that is really where the focus is now. Because many a times we look at new technologies which come up for development, but we somewhere in between lose the focus to take them for deployment. And that's where they sit within our research laboratories and do not get translated to actual products which can then create the impact. We have been able to set up a very robust ecosystem which has facilitated this. Our Honorable Union Minister for Science and Technology, Dr. Harshvardhan ji, who has not been able to join us today because of another, we've got 41 sessions, which are going on parallelly, so his engagement there is in one of the other sessions. His clear message to us in each of these activities that we take on is, any science and technology activity that we take on must have an immediate impact in terms of its societal impact. And if we're looking at the clean energy sector, this is clearly a sector where this impact is not only seen, but it's felt as well. As has been said by Sangeeta, the Government of India has been a very, very active player in the Multilateral Mission Innovation Initiative. In fact, we've been key leaders in it. We've been part of all the 7 innovation challenges. And the government in India has actually led 3 of the challenges. This is also one sector where we've seen an excellent interministerial cooperation between the Department of Biotechnology, Science and Technology, Ministry of Power, Ministry of New and Renewable Energy, Ministry of Petroleum. And we see how the strength multiplies when all agencies come together. It's also been a sector where we've seen the startup community working very closely with our R&D institutes, so that, as I mentioned, taking the technologies to deployment. The clean energy incubator that we've set up it's just one of its kind. In fact, the first one that has been set up amongst all the 25 mission innovation countries. The whole purpose of this clean energy incubator was, how do we encourage and inspire these young startups to take on technology development for a sector which is fulfilling this large ambition of our clean energy technologies. Technologies which are of social relevance like this, it's a little difficult to attract the startup community, but incentivizing them, giving them clear demand, which was projected within the ambitious target, we've been able to motivate them. We've seen the sector growing, whether it's in the solar energy area, whether it's in the smart grids area, whether it's in the area of our biofuels, each of them we've seen the sector growing. So we do now have this vibrant system that is there. We would now look to seeing how we can quickly replicate this model and have many more such. We would also need now to bring in, which we've started doing, a lot of investment opportunities for these startups, because the key factor that is critical and crucial for the success of the sector, and sir, we will need your guidance and intervention in this, is we are talking about scaling this ecosystem, bringing in more startups, but unless and until we bring in very clear policies, sir, which allow this scalable ecosystem to also be sustained, I think at some point of time we will realize that we may not be able to take those ambitions forward. So the scalability and the sustainability of the ecosystem is important. And I think many of the policies that we have brought in, we will also need to bring in the investment opportunities. And I think currently what is the limiting factor for our sustainability of this ecosystem, it's two. One is the innovation levels of our technology, and the second is being able to attract excellent investment opportunities to take them forward. We've already progressed on that line. I'm sure we'll be able to do that. This webinar, which is talking about new technologies, the high level roundtable tomorrow, where we have some of the key industry leaders also going to be present, I'm sure we'll come up with good recommendations. This will also be an opportunity where we can involve many of the younger startups and younger researchers, and we look forward to this to move ahead. I would like to close, sir, once again by just thanking you, but also mentioning here that India today has a large number of international partnerships which have already been spoken of. Our international alliances, whether it's the Solar Alliance, whether it's the Mission Innovation, whether it's the Clean Energy Ministerial, or it's the BioFuture Platform, each one of them has already positioned India in a leadership position. I think identifying those priority sectors now where we would need to build human resource, where we would need to build the infrastructure, where we would need to build new technologies, which will be game changers for our next 4 to 5 years, is currently what we are working in terms of the strategy action plan that is being prepared, which is again being done in consultation with all ministries, in consultation with the international groups. And I think there, the recommendations of these panels, how we engage the younger researchers, how do we have specific policies, how we can build the human resource capacity so that we have a very strong workforce as we move into the next 5 years. I think that really is our ambitious target as we take forward. I will like to close by congratulating all the organizers here, congratulating each of the speakers, and also once again thanking the Honorable Minister for his guidance and his presence here, which is going to be so important for all our startups, researchers who are part of us. Thank you very much for your presence here, sir.
Thank you so much, ma'am, for your insights and thought and for encouraging words for all researchers and scientists. This would be, you are the energy behind these all initiatives. So thank you so much. May I now request Honorable Minister to kindly deliver your inaugural address, please. Thank you so much.
Thank you.
Yeah.
Dr. Reddy Suru, the Secretary, Department of Biotechnology, Government of India. Scientists, researchers, friends, ladies and gentlemen. I'm happy to be here. I believe that this is a great event, and I'm quite certain that this event will lead to many new ideas and many new initiatives. I'm here to tell you about our energy sector. I believe, in fact, not only me, independent researchers have said that India has been a trailblazer in the field of energy. If you talk about energy, there are 3 aspects which are important, which are vital. One is access, the other is sufficiency, and the third is a concern for the environment. Energy transition, we call it. In all 3, we have actually been a leader in the world. If you talk about access, we connected every village in our country, and we connected 28 million new consumers in a space of 18 months. Now, this was the largest expansion of access in such a short time frame anywhere across the world ever. In no other country have so many houses, so many people been connected to electricity in such a time frame, in such a short time frame. 28 million in 18 months. Now we have universal access. We have connected every house. And our message to the world, all the states is that if any house is left out, please go ahead and connect it. So we have achieved universal access. Sufficiency. Now, when our government came to power, we were deficit in electricity, we were deficit. Today, we are surplus. In just about 5 years, we've added 139,000 megawatts in just about 5 years. And today, as I said, we are having a generation capacity which is twice that of our peak demand. Our peak demand is 185 gigawatts, 185,000 megawatts. And today our established capacity is 374,000 megawatts. We are exporting electricity to our neighbors. And the quantum of export will go up. So we have tackled the problem of sufficiency. I'm not saying that we can be sanguine, that we can just rest insofar as the capacity addition is concerned. And I'll tell you why. Our demand is growing. And our demand is growing at a rapid pace. In October, our demand was almost about 12% higher than it was in October 19. And this is a period of COVID, when many economic activities are actually not happening, when the commercial sector, malls, etc. are shut down. Despite this, the growth in demand was 12%. In December, on every day, the demand is 10,000 to 12,000 megawatts higher than the corresponding day in the previous year. Now, this is good news. This is good news that because this means that our economy is growing again. It also means that the 28 million new consumers which we added, they are adding appliances and increasing their consumption. So our demand is going to double and triple in short order. So the fact that today our established capacity is twice our peak demand does not mean much. We have to keep adding. We have to keep adding to our generation capacity because of the way the demand is growing, which is very good news. And we are continuing to add to our generation capacity. The only thing is that now we are adding to our generation capacity, keeping in mind the requirements of energy transition. Now, why do I say that our energy demand will double or it will triple? Because when we started off, our energy consumption was 1/3 the world average. So it's going to triple. So we have been, for some time now, for some years now, past 2-3 years, the fastest growing as far as energy generation capacity is concerned in the world. And we shall continue to be like that for the next 5, 6, 7, 10 years as our demand doubles and then triples. I mean, that is inevitable. But as I said, the third aspect, energy transition. Now, we are a country led by a prime minister, which is very, very sensitive to the environment. And we have also emerged as a leader in this. In COP21, as a part of our commitment, nationally determined contributions, they call it, we pledged that by 2030, 40% of our established capacity will come from non-fossil fuel sources. Today, we are already at 38%. Our established non-fossil fuel capacity is about 140 gigawatts. And the capacity under installation is 62 gigawatts, which means 202 gigawatts, 220,000 megawatts. And this does not include nuclear. If you add nuclear, that is another about 8,000 megawatts, which is also non-fossil fuel, but I'm not including that. Now that comes to almost about 38. I mean, if you take the capacity under installation, it comes to almost about 52%. If you take the capacity which is established, which is about 140 gigawatts, it's 38%. So by 2030, our non-fossil fuel capacity will not be 40%. It will be 65%. We are the fastest growing renewable energy capacity in the world today. And this is not us saying it. This is independent survey saying it. It's Bloomberg saying it. Today, we have emerged as the most attractive destination for investments in renewables. The past 4.5, 5 years, we had investments of $64 billion in renewable energy. Our solar capacity has gone up by 13 times in the past 5 years. Our total renewable energy capacity, if you just take the capacity, the solar and wind, I'm not taking the hydro, the capacity installed and under installation is 4 times what it was when we started, when our government started. So we are a leader in the world insofar as transition is concerned. And we'll continue to be a leader. Because as I said, our demand is growing and will continue to grow. And that demand we are going to meet by non-carbon sources of energy, non-fossil fuel sources of energy, which is solar, wind, hydro, biomass, etc. Renewable energy. Not only this, we are actually the only country of all the major countries. We are the only economy of all the major economies whose trajectory is consonant with the trajectory required to keep the increase in temperature, global increase in temperature, global rise in temperature to 2 degrees. We are the only major economy which is on track for doing that. No other major economy is on track for doing that. And again, we shall continue that. Now, this growth also has with it, we are not only growing, we are growing in an innovative fashion. We've started many new products. We started off with plain solar, plain wind. Now we have bids for hybrid. There were very successful bids. The stability of the energy supply increases. The duration of hours of supply increases. Incidentally, adding so much of capacity has also meant that we have managed our grid well. We've constructed green corridors. We have set up 15 renewable energy management centers, 15, and we intend to set up more. We have stabilized the grid by setting up capacitors and other such equipment, so that such large ingestion of renewable energy, intermittent energy is balanced. And we have been successful at that. As was shown, when the Prime Minister called for 9 minutes of lighting of a lamp. And we managed a fluctuation in the grid of 32,000 megawatts in a space of 9 minutes. The drop of 32,000 megawatts as the lighting went on in the cities, and then again an increase of 32,000 megawatts over a period of one minute. And we managed that. That's because of the way we have strengthened the grid. The other innovations which we have tried is, one of course is hybrid. The other is round the clock. That means we are adding storage. And we are adding storage in a neutral fashion. We are not saying that it has to be battery storage. It can also be pumped hydro. So we are neutral. And we are allowing the market to decide as to what it should be, whether it should be lithium ion or battery storage as you call it, or whether it should be pumped hydro, or whether it should be balanced by hydro. We have had successful bids for peaking power requirements from renewable energy. We have another bid of 2,500 megawatts of round-the-clock energy, using renewable energy balanced with renewable energy of at least 51%, balanced with other forms of energy to give round-the-clock power. We have set up almost about 400 megawatts of floating solar. And we find that the results of floating solar are actually better than ground-mounted solar because the temperature rise is managed better. So the efficiency is going up. So we are adding to that floating solar capacity. Similarly, we now today, in fact, today we have a meeting with the Ministries of Fertilizer and other associated ministries on production of green ammonia using renewable energy, using solar to hydrogen to green ammonia. And I'll be discussing with the Ministry of Fertilizers as to how they should stop importing ammonia which is fossil fuel based, which is produced based on fossil fuel techniques, and rely on indigenously produced green ammonia. So this is the type of innovation we are trying. We are going to set up about 10,000 megawatts of solar generation capacity in Ladakh, which is one of the coolest places in the world. But it has the highest insulation. The insulation is higher than in Rajasthan. All these changes have implications for the system. One implication is, there is another thing which I must tell you. We are also encouraging rooftop individual generation. We are encouraging consumers to become prosumers. 2 days back, we came out with rules outlining the rights of prosumers. That those who are producers and consumers, prosumers, those who set up rooftops, etc., they have rights. Rights to time-bound service. Rights to time-bound net metering. We've come out with rights for prosumers. And we want to make the prosumer the universal category. Once that happens, then the reliance on the grid will come down. The utilization of the grid will come down. Incidentally, in order to expand access, in order to reach connect every corner of the country to the grid, including Ladakh, we added 142,000 circuit kilometers of extra high voltage and high voltage lines, including HVDC lines. Some of the highest capacity HVDC lines are in our country. But as I said, transition means that the reliance on the grid will come down as you have more and more distributed generation. There are, and I'm encouraging efficiencies. For example, we have set a target for greening our islands, which is the Andaman and Nicobar Islands, Lakshadweep. Now there, I have told my people, my officers, that you must use cutting edge, most high, the solar PVs with the highest efficiencies for work sites, etc., which are only in the experimental stage. Now, so every day we are innovating. And we need to innovate, because if you want to green the islands, the availability of land is limited in Lakshadweep. So you have to have PV which has the highest efficiency. We'll try it out for work site and see how it works. Bifacials are being used and will be used more and more. Now we are going to solarize our entire agriculture sector. We are solarizing the agriculture grids, the agriculture feeders, so that electricity is available to the farmer during daytime for irrigation, almost free or at very low price. And we will solarize every agriculture feeder. So that then we will extend it to cooking, solar cooking. That is our ambition. We have already launched a drive for conversion of our mobility to electricity. As I am in the business of selling electricity, so I want mobility also to be converted to electricity. Now, what all this is doing is another thing which is important, which I want to point out, and that is another factor in energy. So we talked about energy access, we talked about energy sufficiency, we talked about energy transition. There's also a question of energy autonomy. When our energy consumption was fossil fuel based, we were dependent on external sources of energy, on other countries. The transition is making us autonomous, independent, because we are generating all our requirements. The sun provides all the energy which we need. And we aim to convert our energy requirements based on that. This has another aspect as well, which I want to point out, the energy transition, and that is lower prices, not only access. Incidentally, there's another aspect which I think you should know. The fact that we achieved universal access was due in some measure also to the distributed nature of renewable energy. We have villages in the Himalayas, in Arunachal Pradesh, in Uttarakhand, in Himachal Pradesh, in Jammu and Kashmir, which have hamlets, one hamlet on one hill and another hamlet 5 kilometers away on another hill, and the hamlet would be 5 or 6 houses. Now running the grid right to across all these hamlets of over 5, 6 hills was difficult. So we went in for distributed generation. So universal access was made possible by our transition. The transition is also going to change the way energy consumption works. And it's going to actually democratize because the prices are coming down. The last bid which we had, the price per unit was 1 rupee 99 paise, below 2 rupees, 1 rupee 99 paise, and going to come down further. Now, what this means is that the energy will be less and less costly. And therefore, what this means is that the poor people will be able to consume more energy. They will be able to buy more appliances. They will also be able to enjoy the benefits of heating and cooling. Like it's winter, I mean, they need heating. Now they will be able to afford the energy. As the energy cost comes down, they will be able to afford heating using electricity. So their standards of living will go up. They will, of course, afford lighting. They are already doing that. Now, these are all other changes which we have brought about. Lighting, for example. Now, this brings me to another fact. Energy transition does not only mean the substitution of fossil fuel-based energy with renewable energy. There is another side to what we are doing. And there also we are emerging as a leader, world leader. And that is energy efficiency. Now, for example, we have a program which is unique in the world called Perform, Achieve, and Create. So we set targets for industries for achieving energy efficiency, bringing down the emissions intensity of our economy and the energy intensity of our economy. We're doing the same work using less energy. It's called, and for industry, we have now 6 cycles going on. It's only the second cycle we achieved efficiencies which has resulted in reduction of CO2 emissions by 61 million tons per year. Second cycle. We have 4 more cycles going on. We launched the Standards and Labeling Program, another innovative program. Now, let me come back to the first program. Now, why do we call it Perform, Achieve, and Trade? It means that an industry is given a target for achieving energy efficiency. Now, if they overshoot that target, they get certificates which they can sell. And those industries which have not managed to meet their targets, they'll have to buy those certificates, otherwise they'll be penalized. They will have to buy such certificates till they achieve that standard of efficiency. And it's working great. And other countries are copying. We have a standards and labeling program. 26 of our appliances we have covered in that. There we set energy efficiency standards for the appliances, air conditioners, refrigerators. You would see the star ratings. They are our ratings. And we outlaw the 1 star and 2 star every 2 or 3 years. So they will not be able to sell 1 star and 2 star. They'll have to upgrade their efficiency. Now that itself is saving almost about 45 million tons of CO2 emissions every year. Now we launched one of the largest programs for replacement of conventional lighting with LED in the world. And I'll just tell you the figures of one of our public sector enterprises. I'm not talking about the private enterprise. We have a public sector enterprise called IISF. Now that sold 36.63 crore, which means about 3,663 million LED bulbs and LED tube lights. The reduction in CO2 emissions was 39 million tons of CO2 per annum. The electricity savings are 48 billion units every year, just by one public sector. And the private sector has distributed almost about 126 crore LED bulbs, not distributed, sold, We have transitioned our lighting right down to the village. We have replaced 11 million street lights with LED street. So energy efficiency. Again, we have emerged as a leader, and we'll continue on that because we want to reduce the energy intensity of our economy. Produce the same goods using less energy, and produce the same goods using fossil fuel free energy, non-fossil fuel energy. So, as I said, this is going to the fact that the energy prices are coming down will lead to the people who are not, whose standard, whose income is not so high, also to enjoy the same standards of living, which today the middle class and the upper middle class enjoy. That is our objective. In Assam, insofar as energy is concerned, we are living in exciting times. All this expansion of access, transition, all this is leading to requirements for innovation. That is where you come in. And this innovation is leading to a better lifestyle for our people. Is leading to energy autonomy. And it is here, in fact, that we are taking action for leaving behind a planet which is healthier than we found it for our great grandchildren. That is the objective of our government and of our Prime Minister. And we are well on our way to doing it. Thank you very much.
So, thank you so much for your given wonderful statistics about how India is aggressively working on 3 aspects: access, sufficiency, and clean energy transition. We are the leaders in this. From this speech, we are from every part of the globe can understand that how India is pursuing cleaner path and also providing access to and affordable access to each one part of the rural part of India. With this, I would thank and I would request Dr. Vinitji, please propose vote of thanks. Can you please?
Thank you. Good morning, everyone. On behalf of Energy Conclave team, it is my privilege to propose vote of thanks. First and foremost, I would like to thank the Honorable Minister Shri Rajkumar Singh Ji, who has graced the occasion at short notice and share his vision and inspiring words with us and give the important facts about the Indian energy sectors. These facts would help us to take our clean energy transition at further accelerated rate. And sir, we are very closely working with all the Ministry of Power as well as the Ministry of New and Renewable Energy in this clean energy transition. I would also like to thank Dr. Renu Saroop-ji, Secretary DBT, for her encouraging words and sharing her perspectives, who always motivated us to work for clean energy transition across the country. I would further like to thank the publicity team as well as the media persons who help us to outreach of our event. I would like to thank the backend team working at DBT, working at Department of Science and Technology, working at National Institute of Science, Technology and Development Studies, Indian Institute of Technology, Delhi, Maulana Azad National Institute of Technology, Bhopal, Vigyan Bharati, who are working relentlessly for past 1 month for making all necessary arrangements to make this event success. I would like to thank all the participants today morning who have joined us for this inaugural session and hope that the deliberations ahead of the day would enrich whole of the energy stakeholder. I would request you to please join our webinar session on showcasing energy technology and also visit our poster gallery to know about the latest R&D development taking place in the energy sector. Thank you very much, sir. With this, I end and hand over this session to our next session coordinator.
Thank you. And with this, we close this inaugural session. Thank you so much, sir, ma'am. Thank you. Thank you, all of you, each one of you. Thank you, Vinitji. Please join us for the other events, the webinar and the tomorrow sessions, please. You all are welcome to join this. So now Dr. Priyanka, would you like to start with this?
Thank you, Dr. Sangeeta. Thank you very much. And we'll now move to the next event, which is the webinar session. I request everybody to join. We are starting. We just start, right? So we are starting with the next session, which is the webinar. So namaste and good morning, everybody. And I, from a very sunny winter morning here at Delhi, I welcome everybody, all the esteemed panelists, students, researchers, every audience who are present here today. Dr. Sangeeta, under whose guidance, the entire energy conclave has shaped up very well. The IISF team, the entire family of IISF team, it's a huge team. It will be absolutely impossible to, to address everybody by name. So it's the IISF family who has put up the work to get the show together. So I welcome you as well. And of course, the session chairman, Dr. D.K. Tully, who doesn't need any introduction. He is an internationally known expert in the area of bioenergy. And due to paucity of time, we are little behind schedule. So I straight away come to Dr. Tully for your welcome address and steering the webinar today, sir. So Dr. Tully.
Thank you, Priyanka, and welcome to this webinar on showcase energy technologies.
Sorry, sir, are your audio is like very bleak. Can we just see that the microphone is
audible now?
No, sir.
Now?
Better?
So, welcome to this session. And we all heard very inspiring talk just in the inaugural session, both by Dr. Renu's and by Honorable Minister, who actually told us how much we are doing in energy transition, energy generation, how India is progressing on this. It's very heartening to know that. Now, we have a panel of very good experts in this. I have known some of them personally. They have done extraordinary work in their area of expertise. So we'll obviously like to listen to all of them. But since my area is bioenergy, so one or two things which I like to make in here. Now, as we know that most of transport sector is on liquid fuel and very difficult to convert this into other forms. So biofuel was thought of one area, and in last few years, we have done quite well. Now, we import 80% of our crude. So it is very important that we part replace some of these transport fuels with this. Now, as Minister also said, that since our GDP is increasing, our standard of living is increasing, so our energy requirement is also increasing. But friends, the challenge is to meet the energy requirement in a responsible manner. That is, we increase energy usage, but at the same time, we reduce GHG emissions. And biofuel becomes one of this area. As it was told in a inaugural session, we are part of Mission Innovation. So I got introduced while working in Mission Innovation, the good work which we have done in several areas, and we are becoming leader in here. Another very important thing which comes out of this is people do talk about very expensive alternate energy. Now, if we look into past history of only 2 decades, when the solar started coming, it was awfully expensive, and some of the critics always said that this cannot be a widespread technology. And we know within last 10 years what has happened, as Minister said, ₹1.99 per kilowatt hour was the latest bid which has come, which is about half the price of coal derived energy. So the same logic applies here, that though all these methanol, drop-in aviation fuel, gasification, algal, biohydrogen, they look to be far away and very expensive, but economy of scale can actually make a difference into this. So I'm very optimistic. Second thing is policy. This government has made a policy interventions which has made things possible. You know, in biofuel policy, we had a target of 20% ethanol and 5% biodiesel, and we said by 2030. I heard only last week the government is trying to change the target from 2030. They said maybe we can achieve it by 2025. So this is the type of policy interventions which can be done. Anyway, we have a very efficient and excellent panel in this webinar. And I will introduce them briefly because time is short and we want to listen to all of them. And I will request the panel to stay on because there will be questions towards the end of panel. And so kindly stay on with this. So I'd like to briefly introduce the panel beforehand, and then we'll have the recorded presentations straight away. Dr. N.P. Padi, IIT Roorkee, is an expert in AC/DC smart grid, power system analysis and economics, and distribution system analysis and pricing. He is very active in mission innovation as well. Dr. Damodran from Amrita Vishwa Vidyapeeth Kochi is on energy storage technologies, which is very important, such as lithium-ion batteries, all solid-state batteries, and supercapacitor. Professor V.K. Vijay of IIT Delhi is very well-known figure, and he has been a torch bearer in biogas technologies for more than 2 decades. And he is also national coordinator of Unnat Bharat Abhiyan presently. Dr. Vanita Prasad, founder and CEO of Revi, is an environmental biotechnologist and has worked 20 years in waste management technology. So different areas people are representing. Dr. Shams Yazdani from ICGEB is a well-known synthetic biology person, and his major area of interest is genomic, metagenomic, synthetic system biology, and he works in advanced biofuels. Professor S.P. Gaun Chaudhary, a special welcome to you, sir. He is a mission innovation champion in this. Basically, electrical engineer, and is very well known to the solar community in this. And his work on field level solar PV off grid is very well recognized. Samita Rakesh is a clean energy incubator, worked for 12 years for advising social enterprises, not-for-profit philanthropies, and public and sector enterprises. Dr. Parvanjit is with 27 years of experience of energy and environment. He is extremely useful experience in developing and vetting the DPRs of techno-economical feasibility reports of MSW projects, which is extremely important. And finally, E. Rajashekhar, IIT Roorkee. He is in the Department of Architecture and Planning, and his area of interest is thermal comfort and energy efficiency in built environment. So if you can see, there is a wide variation in the expertise of all the panelists. I welcome them once again here. I will request Priyanka, you please run the presentations now with all this introduction, and since time is short, and we will definitely have some question answers towards the end of it. My request to panelists to please stay on onto this. Thank you very much.
Thank you. So we will now play the recorded talk one by one, and we will take the questions toward the end. Thank you, sir.
The first speaker is Dr. N.P. Pade from IIT Roorkee.
Greetings of the day. I am Narayan Prasad Padhi, working as Institute Chair and Senior Professor at IIT Roorkee. Thank you for the opportunity to share my thoughts on power system flexibility in accelerating the adoption of renewables. Integrating very high level of renewables is probably one of the greatest challenges for a decarbonized power system in the coming years, and will require significant progress in a number of technological areas. Today, I would like to present to you where we are going or we are heading, and some of the key issues on local power balancing for advancing power system flexibility. Renewable energy, so-called expected to be clean energy, is at the center of the transition to a less carbon-intensive and more sustainable energy systems. Due to the environmental degradation and increasing energy demand, it is very necessary for us to think about the alternative energy resources. Renewable energy sources is the key factor for rapid growth in investment as well as development of smart grid technologies. Renewable energy sources are integrated at the distribution network level in a distribution framework. For the effective utilization of these renewables, demand-supply balance is required at distribution network level, which is popularly known as the local power balancing. Renewable generation is increasing rapidly in India, but since last decade, almost we are very keen to proceed or to move towards more renewable integration to the Indian grids. But even though we are still lag behind in supplying electricity demand through renewable, which is very close to 10 to 13% of the total energy demand or energy consumption today, still electricity generation is dominated by the fossil fuels, due to which carbon emission and global warming are continuously increasing, as told by most of the researchers working in this field. Government of India, however, taken major steps, very wonderful initiatives, and made impressive progress in recent years in increasing citizens' access to electricity. It has also successfully implemented a range of energy market reforms and carried out a huge amount of renewable deployments, notably in solar energy. Looking ahead, the government of India has also laid out an ambitious plan or vision to bring secure, affordable and sustainable energy to all its citizens. The Ministry of Power produces a national electricity plan every 5 years, in which it reviews the progress made over the previous 5 years and set out a detailed action plan for the next 10 years with the overreaching aim of achieving universal access to electricity across India and ensuring that power is supplied efficiently and at reasonable cost. However, achieving the dream of clean energy for sustainable development disrupts the operation and management of our legacy power grid due to lack of flexibility when higher share of renewables are integrated into the system. Just to be very precise, especially due to the huge amount of renewable integration, the base and the thermal, coal, nuclear power plants do face a great challenge to adapt, with the intermittent regeneration and its penetration to the grid. So I think this is the future where we need to promote renewable as well as we have to encourage flexibility to accommodate those huge amount of penetration into the conventional grid through renewables. The intermittent nature of renewable will cause reliability and interoperability issues when connected to the existing power network. To address the challenges related to the integration, operation and management of renewable-based power generation, flexibility is needed in different segments of the power system. Mainly, these segments are transmission flexibility, distribution flexibility, storage flexibility, market flexibility, etc. And the diagram very clearly talks about different domains of flexibility, and we can utilize those domains for overall flexibility options, which can be extracted to achieve or to make the system more flexible in nature. In general, the flexibility can be defined as the ability of a generating unit to change its output, ramp up or down rapidly, start and stop with short notice, and achieve a low minimum turn down level. At the transmission level of flexibility, options have been researched well and established. However, at the distribution level, flexibility option is an ongoing research and not well established. This demands exploring the role of localized power balancing for advancing the power system flexibility, and probably during my end of lecture, I will try to demonstrate 2 case studies how flexibility can be exercised through both simulation platforms as well as hardware test beds. Moving to local power balancing, with the inclusion of heterogeneous sources like PV, wind, along with other renewables and fossil fuel sources, the coordination and its control will be a challenging task, and the need increase manifold. Local power balancing aids in upscaling the renewable energy generation, provides solutions such as storage integration and demand response, helps to reduce transmission and distribution losses, and ensuring reliable power supply to its customers. The responsibilities of local power balancing are taken by the following tools and operations. Demand response, it's the ability to set demand according to the power generation, helps in peak energy management. Microgrid technologies helps in effective utilization of renewable energy sources through better operation and management capabilities, which improves the reliability and resiliency of the power system. Storage integration. Storage system provides flexibility through the peak management of electricity demand by effective utilization of local energy generations, especially through renewables. Aggregators allow small consumers to participate in electricity market, provide energy to wholesale market and ancillary service to the grid operators. Electric vehicles. EV charging and discharging in coordination with the grid operation helps in mitigating curtailment of renewables. TSO-DSO integration. Effective coordination of TSO-DSO provides opportunities for the DER operators to manage their resources according to wholesale electricity market. Now, when we talk about major challenges in the area of local power balancing, these are the following points need to be given a lot of attention, and they are aggregation of different resources, coordinated control of heterogeneous sources, price decision making, optimal placement and sizing, flexibility and time of availability of the resources, the ramp rate limit to maintain the stability while balancing. With the inclusion of heterogeneous sources like PV, wind, along with other renewables and fossil fuel sources, the coordination and its control will be a challenging task, and the need for local balancing will increase manifold. And finally, inertia emulation to play an important role in local power balancing.
Good morning, everyone.
Thank you, Bharti. Can you play the second presentation, please? Hello. Yeah.
Good morning, everyone. It's my pleasure to be presenting here at the India International Science Festival Energy Conclave. Myself, Damodaran Santanagopalan, an associate professor from the Center for Nanosciences, Amrita Vishwavidyapeetham, Kochi campus. I'll be presenting briefly about the work that we have been doing at the center on the development of battery technologies at Amrita. And energy storage is one of the key important aspects as far as the challenges that India is facing as a developing country. And especially transition from non-renewable to renewable energy sources is actually a global challenge. And we need technological developments in this particular aspect, especially energy storage is important from consumer electronics to grid storage to electrical vehicles. And ambitious goals with what we are facing in the future for the energy storage while going renewable, it's very important to focus on the energy storage technologies as well. And it is important to develop indigenous lithium and sodium-ion battery technologies with scale-up capabilities, which would be very vital from the Indian perspective, because there are gaps and challenges that we will be facing for this particular development. This particular picture on this particular slide on the left-hand side shows the important transition metals and the resources that we have for battery technologies available within the country and other countries where these resources are available. And this is particularly a chart from Niti Aayog, India. And we know that lithium and sodium resources are limited in the country, which we look forward from other countries, but India is one of the largest producer of manganese, which is one of the vital transition metal in battery applications. We also have highly available resources of titanium, graphite, vanadium, and zinc kind of sources. And also nickel resources are available in the neighboring friendly countries, which is basically very important for developing battery technologies. And energy storage research at Amrita has been focusing on several battery applications, such as lithium-ion, sodium-ion, and potassium-ion batteries, while we are also interested in solid-state batteries and battery recycling and supercapacitors. In this particular presentation, I will just focus on one particular cathode and anode material that we have developed at Amrita as an indigenous technology, including scaling up of these two materials, which is spinel lithium manganese oxide cathode material and lithium titanate as an anode material for high power battery applications. The cathode, which is known material, but the problem with this particular material is the manganese transition metal dissolution, which is basically, bottleneck for this particular material to be widely applicable for battery applications. But one of the main problems is that this particular material, this manganese, is having a dissolution problem because of the manganese 3+, which is interacting with the electrolyte, and that leads to dissolution. So what we have developed is a surface engineered manganese, lithium manganese oxide spinel material, where we have enriched the surface with the majority of the surface is having 4+ rather than 3+, which can stop the dissolution problem. So this is also further established by doing a depth profiling of the X-ray photoelectron spectroscopy, where we can see this particular manganese is basically surface 4+ rich, while the 3+ is basically equal almost when we get into the depth of the material. So it's only surface is 4+ rich. And this leads to very high rate capability, which is high power performance and long cycling stability. For instance, we demonstrate here, the discharge capacity retaining more than 70% when we are, testing these batteries up to 60 C. 60 C is basically 1 minute of charge, 1 minute of discharge. And in this particular case, you can see the cycling stability for about 1,000 cycles. The retention at 10 C is still almost 90%. And equally, we need high power anode materials, and we have developed lithium titanate as a high power anode material, where we can see that, unlike the conventional lithium titanate, the surface engineered lithium titanate that we have developed can retain very high capacity at very high rates. And also the cycling stability could be almost like 88% of retention after 2000 cycles at a high rate of 50 C charge and discharge. Now, these materials were selected to be, making a full cell lithium ion battery, which can perform at, high rates. So we could show that in a simple coin cell, 4 high power LEDs can be lit parallelly, driving the current from the single coin cell. And a very high rate performance of up to 200 C can be tested. 200 C is basically charging and discharging the battery within 18 seconds of this particular coin cell that we have demonstrated. And also this battery can perform at very high rate for long cycling, as well as at different temperatures. For example, 25 degrees room temperature, 55 degrees high temperature, and minus 10 degrees Celsius is basically the low temperature operation at a very high rate of 100 C. So it can operate at a wide range of temperatures. And the scale up of this particular material is, of course, is also possible that we have demonstrated. So if we have a 3-liter beaker by the Solger process, we can make 260 grams of the spinel LMO in a single run. And while scaling up this particular case can also lead to, high power performance of this spinel material, where we can see that even after the scale up for 0.5 kilogram that we have demonstrated in our lab, we can retain the same kind of 70% at 60 C, and also almost 80% retention at the end of 1,000 cycles. Not only at this room temperature performance, even when we test it at high temperature of 55 degrees Celsius, it still retains almost 67% of its capacity at 60 C, and also retains almost 75% at 55 degrees Celsius for the long cycling. This is at 55 degrees Celsius, whereas conventional manganese materials will lead to failure and won't work at such long at high temperatures. And similarly, the lithium titanate was also scaled up to 0.5 kilogram in our lab. And that also shows the scaled up material can also retain high rate capability as well as long cycling stability. And so basically what we try to demonstrate in this particular case is that we have scaled up both the cathode and anode material for high power lithium-ion battery applications. We have developed, fabrication of a prototype demonstration of the capabilities of full cell is under progress. It's high rate, long cycling stability, different high temperature, low temperature stabilities at all. Stabilities are tested, and it's a pretty good material for the next high power batteries, and the prototype is in the progress. And these are some of the recent publications and patent from our group. And this particular project is supported by the Department of Science and Technology, Government of India, and we also acknowledge the support from Amrita Vishwavidyapeetham. Thank you. Good morning, everyone.
May I request all the panelists here? Some of the questions are very simple questions like what's the full form of LMO? So I understand that while I would appreciate you if you could look at the question answer round and if you could address that, because majority of some of our attendees are school students and they have some very basic questions. So if you may answer the question while your session is going on. So thank you. Bharti, please play the next video.
Yeah, thank you, Dr. Damodaran, for his talk. Next speaker is Professor V.K. Vijay. He's National Coordinator of UBA.
एनर्जी फॉर सेल्फ रिलायंस एंड ग्लोबल वेलफेयर के एनर्जी वर्टिकल में बात करने के लिए इकट्ठा हुए हैं। आत्मनिर्भरता एवं वैश्विक भले के लिए स्वच्छ ऊर्जा, ये एक बहुत महत्वपूर्ण विषय है कि किस तरह से विज्ञान को जन जन के साथ हम जोड़कर और उनको अपनी भाषा में ही अपनी बात करके इस गति को आगे बढ़ा सकते हैं। यदि विज्ञान अंग्रेजी आधारित ही रहेगा तो खाली जो इलीट लोग हैं वहाँ उन्हीं तक ये पहुँच पाएगा और आम आदमी इसके साथ नहीं जुड़ पाएगा। हमारे देश में जो विज्ञान की परंपरा रही है वो आम आदमी के साथ उसका जुड़ाव रहा है। पुस्तकें भी उनकी बोलचाल में और मातृभाषा में हो तो ही अच्छा है। 1500 से 2000 वर्ष पहले हमारे विज्ञान दुनिया का सर्वोपरि विज्ञान था। हमारा दर्शन, हमारा परिवेश, हमारा खान पान, हमारा व्यवहार विज्ञान सम्मत था। कौन से मौसम में क्या खाना है, क्या व्यवहार करना है, यही जीवन का आधार था। ऊर्जा की बात करें तो सबसे पहला आधार ये बनता है कि वह हमारे पर्यावरण को प्रदूषित नहीं करे। जहां पर ऊर्जा स्रोत उपलब्ध है वहीं पर उनका उपयोग हो। जो ऊर्जा संसाधन को हम स्थानांतरित करके एक जगह से दूसरी जगह ले जाते हैं वो पर्यावरण को प्रदूषित करते हैं। पूरी दुनिया में आप देखिए कि कोयला, पेट्रोलियम आदि के उपयोग से प्रदूषण फैल रहा है और क्लाइमेट चेंज हो रहा है। ऊर्जा की एक केंद्रीकृत जो व्यवस्था बनी है जिसमें हजारों मेगावाट और गीगावाट हम ऊर्जा पैदा करते हैं पावर प्लांट में कोयले और डीजल से, उसकी वजह से पर्यावरण प्रदूषण फैलता है। और जब हम उसको वापस जहाँ पे ऊर्जा यूज होती है वहां तक ले जाते हैं तो उसमें बहुत नुकसान होता है। हमारे देश में लगभग 1/3 ट्रांसमिशन, डिस्ट्रीब्यूशन और थेफ्ट में नुकसान होता है और उसकी वजह से उसकी कीमत ज्यादा हो जाती है और पर्यावरण प्रदूषित होता है। पिछले 100 वर्षों में जितना भी पर्यावरण को नुकसान हुआ है और वो जो क्लाइमेट चेंज में भागीदारी बनी है उससे हमको ठीक करने की जरूरत है कि हम कितने ग्रीन हाउस गैस इमिशन को ऊर्जा के माध्यम से कम कर पाएंगे। इस विषय पर भारत की सोच अलग है और इस कॉन्क्लेव में उद्देश्य में हम भारत को किस तरह से ऊर्जा क्षेत्र में आत्मनिर्भर बना सकते हैं उसका मॉडल हम पूरी दुनिया को दे सकते हैं, जिससे कि हमारे पर्यावरण का भी भला हो, पूरी दुनिया का भला हो और इसके साथ ही हम रोजगार भी पैदा कर पाएं। आज हम लगभग 80% के लगभग पेट्रोलियम प्रोडक्ट्स का इंपोर्ट करते हैं जो कि लगभग 9 लाख करोड़ से भी बराबर है। गांधी जी ने देश को आत्मनिर्भर बनाने के लिए ग्राम स्वराज के माध्यम से उसको आगे बढ़ाने की बात कही थी। IIT दिल्ली में हम लोग जो 300 एकड़ 21 एकड़ का कैंपस है, उसमें 7 एकड़ हमारे पास ग्रामोदय परिसर है। उसमें जितने भी हमारे पेड़ लगे हैं, उनसे हम लोग की जो टहनियाँ और पत्तियाँ मिलती हैं, उससे प्रोड्यूसर गैस बनाते हैं। जो नॉन एडिबल ऑयल सीड्स जैसे महुआ और करंज और उसके पेड़ हैं, मिलता है, उनसे बायोडीजल बनाते हैं। 200 घरों से हम लोग किचन वेस्ट लेते हैं और बायोगैस बनाते हैं। बायोगैस को हम प्योरीफाई करते हैं और प्योरीफाई करके मेरी गाड़ी भी चलाते हैं। पिछले 9 वर्ष से हमारी गाड़ी बायोगैस पे चल रही है और उसको पेट्रोल पंप जाने की जरूरत नहीं है। हमारी जो ग्रामोदय परिसर में 7 एकड़ जमीन है, उसमें 2 लेबोरेटरीज हम इसी ऊर्जा से बिजली पैदा करके चलाते हैं, जो कि बायोगैस से, जो कि बायोडीजल से और प्रोड्यूसर गैस से बिजली बनती है। इसी तरह से हम इस मॉडल को गांव में ही लगा सकते हैं कि वहां पे जो संसाधन उपलब्ध हैं उनको उपयोग करके हम बिजली पैदा कर सकते हैं, ताकि चाहे सौर ऊर्जा हो, पवन ऊर्जा हो, पशु ऊर्जा हो, बायो ऊर्जा हो, इनको उपयोग करके इंटीग्रेशन के माध्यम से हम 50 किलोवाट से लेकर 500 किलोवाट तक के सिस्टम गांव में लगा सकते हैं और उनके माध्यम से पूरे गांव को हम डिसेंट्रलाइज व्यवस्था के साथ जोड़ सकते हैं, ताकि सेंट्रलाइज पावर की जरूरत नहीं, गांव में ही ऊर्जा पैदा हो और गांव में उसका उपयोग हो। तो पूरी दुनिया में जो पर्यावरण प्रदूषण फैल रहा है, उससे हम बचाव कर सकते हैं। जब हम इस तरह की व्यवस्था, जिसको हम ग्राम ऊर्जा स्वराज कहते हैं, की कल्पना करेंगे, उस पर काम करेंगे और उसको लगाएंगे पूरे देश भर में, जो 7 लाख गांव हैं, वहां तक हमारी ऊर्जा व्यवस्था पहुंच सकती है। हमको ऊर्जा की इंपोर्ट की जरूरत नहीं पड़ेगी। मेरे जैसे मेरी वैगन आर बायोगैस की गाड़ी पिछले 9 साल से चल रही है, उसको पेट्रोल पंप जाने की जरूरत नहीं है। उसी तरह से गांव में भी चाहे ट्रैक्टर हो, चाहे 2 व्हीलर हो, वो लोकल हमारी कंप्रेस बायोगैस से चल पाएंगे। बिजली हमारी जो मैकेनिकल पावर है, जो कि आटा चक्की हो चाहे दूसरी हो, वो उससे चल पाएगी, प्रोड्यूसर गैस से। और बिजली हम पैदा करके बिजली को काम में ले सकते हैं। तो इन तरीके से हम ग्राम ऊर्जा स्वराज का एक मॉडल हमने किया है। हमारे एक स्टूडेंट ने उस पर PhD किया है और उस मॉडल का नाम हमने रखा है ग्राम ऊर्जा स्वराज। उसके माध्यम से हमें गांव की अर्थव्यवस्था सुधरेगी, गांव में रोजगार मिलेगा, गांव डिसेंट्रलाइज वे में जो गांधी जी ने कल्पना की थी, उसके माध्यम से हमारे देश की जो व्यवस्था है रही है कि किस तरह से आगे हम आत्मनिर्भर गांव आत्मनिर्भर बने, देश आत्मनिर्भर बने, उस दिशा में आगे बढ़ सकते हैं। मुझे आशा है कि हम सब मिलकर इस संकल्पना को साकार करेंगे और ग्राम ऊर्जा स्वराज को गांव तक पहुंचाएंगे, ताकि सेंट्रलाइज एनर्जी की जरूरत नहीं पड़े और डिसेंट्रलाइज वे में वहां के उपलब्ध संसाधनों के माध्यम से हम उसके ऊर्जा की आपूर्ति कर सकें। इससे पर्यावरण सुधरेगा, अर्थव्यवस्था सुधरेगी, देश आत्मनिर्भर बनेगा, गांव आत्मनिर्भर बनेंगे। इसी शुभकामना के साथ मैं अपनी बात समाप्त करता हूँ।
Thank you, sir. Thank you so much. Next speaker is good morning, one and Dr. Vanita Prasad.
All attending the webinar. I am Dr. Vanita Prasad, an environment biotechnologist pursuing my passion of converting waste to energy for past 25 years. Water scarcity have emerged as increasingly important and vital issue for the world. India's quest for energy security and sustainable development rests a great deal on its ability to tap energy from the renewable resources. To contribute to achieve this goal, I floated a startup, Revi Environment Solution Private Limited in Vadodara. As we all know, nothing is waste, but it's just a thing placed at the wrong place at the wrong time. And we just need a right way to manage the waste so as to get best out of it. And this is the basis of the circular economy, that is continuous use of the resources. More so, till now we are working on to the linear economy, that is use and throw concept, which has led to the many issues leading to the climate change. So only way now is to change mindset of everybody that nothing is waste and it is a precious resource which we need to save. On the other hand, over-exploitation of fossil fuel has led to greenhouse gas effect. Although greenhouse gases act like a blanket for the earth and without them, the temperature would be like minus 18 degrees most of the time. Excess emission of our modern world produces extra greenhouse gases, gradually causing warming up of the earth and leading to the climate change. Result of the same has been indicated as climate performance indicator, and hence we all now are focusing on reducing our carbon footprint as indicated in the graph by positive growth in the renewable sector. Experts have been harping upon the need to use biomass to produce clean energy for achieving sustainable development, and it is now at the forefront of the global agenda. Very recently, Niti Aayog and Embassy of Netherlands has signed an agreement to support the decarbonization and energy transition agenda for accommodating clean energy. India is facing an acute energy deficit issue. As a result, about 89% of rural and about 28% urban household depends on the polluting source for energy, such as firewood and dung cakes. Secondly, India happens to be the fourth largest emitter of greenhouse gas in the world, accounting for approximately 4.7% of the total global emissions. The potential of biogas in rural area is about 45,809 million cubic meter per year from the livestock manure only. Rural India can generate about 61 cubic meter per capita per year biogas for the entire rural population, along with simultaneous reduction in methane emission to an extent of 0.016 tons per capita per year. There are other alternatives too, like solar and wind. During the pandemic lockdown stages, we have observed its positive effect on our environment that has accelerated the quest to exploit carbon neutral and carbon negative options. And moreover, our domestic crude oil production can meet only 17.9% of our demands, while the rest is met from the import crude oil. Hence India's energy security will remain vulnerable until alternative fuels are developed based on to the indigenous produced renewable feedstocks. Biogas or biomethane production using waste is a sustainable option as it can substitute natural gas upgraded to a standardized specification which can be directly injected into the natural gas grid, or other option is bio-CNG for transport sector. Our government has taken an initiative to set up 5,000 biogas plants under the Satat program. The world is moving towards the bioeconomy, so as our target is to make India a $100 billion bioeconomy by 2025. At present, our bioeconomy is valued at $33.6 billion and contribution of various segments is shown in the table. Bioindustrial segment is 11% of the total bioeconomy, of which enzyme contribute 52% and biofuel sector contribute 48% total bioeconomy industrial segment. Moreover, India's national biotechnology development strategies lay major emphasis on the generation of biotech product processes and technology for enhanced efficiency, productivity, cost effectiveness in all these areas. Biogas or renewable gas or substitute of natural gas is produced through a process of anaerobic digestion of any biodegradable material. And coupling of this biogas to its market, that is electricity, gas or heat sector respectively, has immense potential for decarbonization. This table shows the nutritional and energy potential of various waste. Food waste has a maximum potential for biogas production, while the pineapple waste has maximum nitrogen. So digestate of these waste can be used as an organic fertilizer for organic farming. Anaerobic digestion or anaerobic technology is the center of processing of any biodegradable material to various useful products. Biomethane production can be accelerated by increased investment in anaerobic digestion process or by improving or implementing innovative, robust consortia for bioremediation. Only MSW can contribute to drop fossil fuel consumption by 20%. 1 ton of such waste has a potential to drop it to 20%. Now coming to our waste to value co-digestion concept, wherein we want to focus on to the septage or the fecal waste. Given the mindset we have about the fecal waste is that it is an expensive liability. But if we look into the physical and chemical characteristics of the fecal waste, we will come to a conclusion that the black water is an ideal feedstock for anaerobic digestion. Also, it has been reported time and again that when the fecal waste is processed through anaerobic digestion, around 90 to 95% of pathogens has been killed or can be eliminated. So keeping this in mind, I have been working on to the development of a cost-effective and indigenous process of making robust consortia for treatment of waste or wastewater to recover energy, nutrition, and the reuse of water. Our work has got an impedance due to ongoing Swachh Bharat mission of Government of India, and we will help to achieve SDGs goals 6, 7, 11, and 13, as it is a scalable and can be done at multiple locations, both in public and private, and have a large social impact as it can provide energy and irrigation water along with the waste management. And experts say that sewage is the black gold and we have a lot of it. In our country, the problem associated with waste or wastewater reuse arises from its lack of treatment, and we want to give that solution. Wastewater from industrial process or from the municipal sewage contains significant amount of organic matter that can be removed or can be converted to energy using our robust consortia. And reuse recovery means extraction of energy from a waste. We are based out of Baroda, Gujarat, and anyone who is interested in connecting with us for understanding our technology solution can reach out to us using any of these contact details. Apart from thanking our support partners, I would like to thank to DBT, BIRAC, which has created a vibrant ecosystem for innovation to thrive in, and IISF 2020 organizer for providing me this platform to share my view on the topic. Thank you all for.
Thank you so much, ma'am.
I'm Dr. Sham.
Our next speaker is Dr. Shams Yazdani from ICGB Center of Advanced Bioenergy Research.
Shams Yazdani. I'm a coordinator of DBT ICGB Center for Advanced Bioenergy Research, situated at International Center for Genetic Engineering and Biotechnology. I'm going to tell you the work that is going on in our center on advanced biofuels. We basically work on two kinds of biofuels, second generation and the third generation. The second generation biofuel deals with the biofuel produced from the agricultural residues, while the third generation is the biofuel which is produced from algal biomass. So these are the two areas that we work on. Today, I'm going to tell you more about the second generation biofuels and the strength that we depend upon from our bioenergy centers. Faculties are in the area of genomics, systems and synthetic biology, and the fermentation technology. We also support Department of Biotechnology by having a mission innovation India unit office, which is basically accelerating the clean energy research and development program. It's a global program. throughout the world. So the major reason why we work on second generation biofuel is because we have a surplus of agricultural waste and residues that are available in India, and we prefer to use that residue instead of something that is used for the fuel purpose for producing biofuels. And there's a lot of incentives from the government to use that, also mainly because it is burnt and responsible for a lot of pollution in the environment. So this is a flow chart which suggests how we can make fuel out of the agricultural residues. Agricultural residues are composed of lignin, hemicellulose, and cellulose, and we are majorly interested in the carbohydrate portion, which is cellulose and hemicellulose. However, it is difficult to hydrolyze these because of the recalcitrance, and it needs enzymes, which is very expensive. That become one of our major research area. It also has significant quantity of C5 sugar, which is not fermented by yeast, and therefore it has to be engineered to be producing ethanol from C5 sugar. And also we work on advanced fuels like butanol, long chain alcohol, and alkane. So in terms of the enzyme, which is a major thrust in our center, we have a high throughput robotic system to screen large varieties of strains for production of efficient enzymes. And we discovered in that whole strategy a new kind of enzymes. For example, one of the exocellulase that we discovered was 5 times more potent than the industrial counterpart. We also develop tools, genome engineering tools, so that we can efficiently engineer the genome to produce high quantity of enzymes. So one of the platforms that we are working on the Penicillium phenoplosum, we have developed the genome engineering tool. We have deleted one of the catabolite repressor, and we overexpress some of them to produce more and more of enzymes. So for example, we overexpressed LPMO and CBH1, which are the key enzymes for producing cellulase and hemicellulases. And as we can see, there are corresponding increase in the efficiency and the titer of enzyme as we do the genome engineering. We compared our various generations of enzyme with the best available enzymes in the market, which is CTEC3, and we realized that the efficiency of the enzymes that we generated through engineered strain is much better. It needs less enzyme as compared to the commercial counterpart. And therefore, the enzyme technology at this moment, we are scaling up to 5,000 meter scale, and it will soon be available for commercial application. The important thing is that this particular technology has already been granted the US patent, and therefore it will be available very soon for commercialization purpose. The other important thing about lignocellulosic biomass or second generation biofuel production is the C5 fermentation, because there are 30% of sugar which are C5 in nature, and typical yeast cannot ferment it, and therefore we engineered a bacteria that can ferment C5C6 sugar into ethanol, and we do that by rewiring of the internal pathway, doing various evolutionary engineering, and we can see that more than 10% of the C5 sugar can be fermented to 5% of ethanol with very high yield of more than 90%. This technology was also US patent granted. While ethanol is a very good candidate, it is having a less energy density and hygroscopic problem. Therefore, we work on other advanced fuel like butanol, which is drop-in fuels. We try to do the metabolic engineering because the native host is not very good in producing high quantity of high titer of butanol. It has other issues for scale up, and therefore we engineer the genome of bacteria using CRISPR-Cas9 method to produce butanol along with the pyruvate, which can give a value addition to overall technology. The other important molecule that we work on is hydrocarbon, because basically the fossil fuel has a major component as hydrocarbon in them. And the major advancement happened in the science when bacteria was shown to produce hydrocarbon itself. So we have taken this strategy further, and we did various discoveries to identify new enzymes. We did a lot of metabolic modeling and engineering, and engineering of protein also to make it thermostable, to produce a very significant quantity of hydrocarbon by doing a 3-gene addition and 8-gene deletion. And finally, the bacteria is producing around 12 grams per liter of citral alcohol and 3 grams per liter of alkane. So all these activities have been patented and covered very well in the national news media. And I would like to acknowledge my students, the collaborators, and funding agency for giving the opportunity to reach to this stage where we are. So thank you.
Thank you so much, sir. Next speaker is Professor Gon Chaudhary, from President NBIRT and Mission Innovation Champion.
At the outset, I must thank the organizer for giving me opportunity to speak here about the renewable energy technologies which are relevant to Indian condition. IISF is a very wonderful event in the country. Every year they are organizing this. So I will be speaking, really I want to speak about the rural electrification program with renewable energy technologies. Little bit I will touch upon because time is very short. So I'll touch upon a little bit on this sector. Indian villages have been electrified. It is claimed by the Power Ministry, Indian villages have been electrified. It is true, electricity has gone to all the villages of India. But the one important issue is, number one, the electricity has gone to all villages, but it is not reliable. That is number one. Number two is, the villages are electrified, but not the all households. Many of the households, in fact, more than 20 crores household of India, 20 crore population of India, they don't have any access to electricity even now. So what we do with those people? Should we wait, or should we start now itself? Now, in order to give them electricity, in order to give them access to energy, renewable energy plays an important role. The renewable energy means there are many forms of renewable energy, like solar energy, biomass energy, mini microhydro, geothermal, tidal power. A lot of renewable energy sources are there. We are all aware about that. But in the Indian villages, if we want to really explore the renewable energy technologies, then two technologies I should suggest, which are very important and very relevant. One is biomass-based technology, which can be utilized very easily in the villages because biomass is available in the Indian villages in plenty. And other one is solar energy, because solar energy is available everywhere in the country. In Indian villages, in any villages, if I go, I may not get electricity, but I get solar energy in all the solar radiation in all the villages. So let me speak about why Indian villages need energy. Basically, if we analyze the villages, they require energy for some different purpose. In urban areas, they need electricity, they need energy for air conditioner, for television, for geyser, water heating, a lot of lighting, a lot of fan, a lot of computer application. So this is the requirement of urban people. But side by side, if we compare the rural people, their electricity or their energy requirement is little bit different. They need energy. Most of the energy they need for cooking purpose, the lighting purpose, and little bit for irrigation and little bit for drinking water. Basically, these are the 4 areas where really they need energy in the villages. In the villages of India. Now, for the cooking energy, LPG system is really, even now, it is a dream for many of the people, though LPG has reached many remote areas, but even now, this is quite expensive. The time it reached in the remote areas, it is very expensive. So, for cooking purpose, still Indian villages, they need, depend on biomass. And biomass-based cooking, one important thing, biomass is a renewable energy source. And biomass-based cooking, now biomass-based cook stoves are available in the country. A lot of good quality and a lot of innovative cook stoves have been developed in the country, which could be easily utilized for the rural areas. And it is interesting to note, there are many entrepreneurs now in the country who are manufacturing cook stove, biomass-based cook stove, which are really useful, very efficient, I should say. And if they are combined with solar power for draft, little bit solar power, then it is a complete solution. It is a complete solution for the rural people. And this type of biomass-based cook stove, they can use in rural areas, the rural people. One of their problem is getting of firewood. So this type of cook stove, reduces the consumption of firewood and very, very efficient, and they are smoke-free. The pollution level, indoor pollution level is very low. So this is one unique example, the biomass-based cook stove developed by different Indian organizations, which could be now utilized in Indian villages. That is one. As I have mentioned, second energy requirement in the villages is for lighting, which is very important. And for lighting, solar energy, out of many forms of renewable energy, lighting need of the rural people, solar energy appears to be very, very interesting, very, very attractive. There are many types of solar lighting. One very simple solar lighting system is the solar home lighting system. The solar home lighting system comprises of, any solar lighting system comprises of a solar PV panel, which is heart of the system. PV panel comprises of solar cells, and one PV panel, nowadays PV panels are available at higher capacity, also 350 watt, even 370 watt PV panels are available. But nevertheless, small requirement, for the villager who is having small requirement, he can go for 75 watt solar panels also, or 50 watt solar panel. So these are modular in nature. It starts from 20 watts, 30 watt, 40 watt, up to 350 watt, they can go. All the solar home lighting system, they comprises of solar modules. Then they have a battery. Nowadays, good batteries are available. The life of the batteries are quite high now, 5 to 6 years, 6 years life. And even the lithium-ion batteries are available for solar home lighting system. The lights are very powerful. The lights are very efficient, and really this could be utilized for the rural people in a very, very good way, and they can use the solar lighting system for about 6 to 7 hours every night. So this solar home lighting system is very popular in the country, but side by side, in villages we also need solar electricity for street lighting purpose. And for street lighting purpose, when the lighting is little bit different. In street lighting we need a pole, but same solar panels are required, and the LED lights. The interesting point is solar home lighting system or solar street lighting system. Initially the cost was very high, it was expensive, but nowadays the cost of solar power has come down. It is now very low.
Thank you, sir. Next speaker is our Mr. Raje, Chairman and Director of Artec Solonex Private Limited.
Hello everyone, this is Amit Raje here from Artec Solonex Bhopal. Very happy to be a participant in this track, which is focusing on energy at the India International Science Festival. Let me share a little bit about my motivation and my journey in looking at energy and working at the intersection of innovation and entrepreneurship. I think no one really needs to be told that that we all have in today's times. But having said that, we all experience a great need of improving the level of energy consciousness that percolates through the society at large. And we have seen historically how energy has shaped the progress and the challenges that the world faces. The Sustainable Development Goal 7 talks about a unified mission in the world to look at energy holistically and reach some sustainability objectives. In terms of the technologies, I think there is a lot of work, obviously, that's happening in the realm of research as well as applications. And a lot of technologies are coming of age very rapidly. Solar power generation being the most popular example, but energy storage is not behind. We do some work in that area, particularly supercapacitors for pulse power applications. And we have seen that the breadth and the depth that needs to be charted to deal with the kind of challenges we all face are very immense, at the same time very exciting and very challenging. The call really is to bring into ourselves the scientific temper, to look at our problems and then solve them in a very methodical manner, in a very conscious manner. And the issue with that is, do we really care? When it comes to technology, we know as technologists that technology has a lot of answers, but not all the answers. The real issue comes as to when the society applies a great deal of scientific temper. And I think this endeavor to bring about and harness scientific temper in the next generation becomes very important. One of the areas of my work is also around working with startups. We run a startup incubation center called IISF RTech and work with a lot of upcoming innovators, makers, startups, and entrepreneurs. Recently, we connected with an interesting student startup called Physics Mind Boggler. And their entire focus is how to bring upon a great deal of interest and activity in the world of popularizing physics, but taking it to the next level, connecting it with entrepreneurship, coming out with the next generation of technologies that will solve today's problems. And it's amazing to see the youthful zest and energy that they bring on the table and the optimism with which they are looking at cracking some of these problems. Again, in the world of energy, world of smart grids, world of energy storage, world of electric mobility, we have realized that energy being a need that everyone faces is creating more and more challenging and complicated problem statements. And it will need a special focus, a special applied, entrepreneurial, engineering, as well as scientific temper after each of those problems. Simply, we were in touch with the Indian Army, and they were looking at trying to solve some of these problems of engines starting in cold conditions. And we have done some work in supercapacitors, which are pulse power devices. Now, at the lab level, these applications look fine, but when we really have to put ourselves on the task and try and see whether they work at -30, -40 degrees, it's a whole different ballgame. And it was so fun and educating at the same time to really develop solutions, end-to-end solutions, and really get those tanks started under sub-zero conditions. So I think there is great scientific talent and historical perspectives that we have in India. We just need to develop that confidence to take ownership of our problems and keep hacking at those problems in a very liberal and scientific manner, questioning everything that comes our way and getting into those next level solutions with a great deal of innovation and entrepreneurship. For the students who are also listening, I would say I would always recommend look at the 5 high approach. Every time you see something being thrown your way, ask why for it, get more 4 of it. And, we have all built our scientific foundations on the work done by our great predecessors. But this is one question that constantly needs to be asked. And that is what will be the turning point in bringing out new innovations, new discoveries. I think the issue has come where we have to apply ourselves in such a manner. Particularly the COVID-19 situation has helped us understand these issues very well. That disruption is in the air. There is an opportunity to bring about a great deal of innovation in the way we think, the way we act, the way science needs to be understood and applied. And I've come across numerous examples of people who are doing some amazing ground level work in the field of education, in the field of application, in the field of research. And I think we need to figure out ways to connect these dots and ultimately get a great deal of innovations and entrepreneurship happening. So on that note, I wish this event all the success, great success stories in the near future. Thank you so
much. Thank you so much, sir. Next speaker for the day is Miss Smita Rakesh. She is from Clean Energy Incubator Strategies Private Limited.
I'm Smita Rakesh, and I'm the Portfolio Director for Clean Energy and Climate Action at Social Alpha India. This is a pre-recorded message, so I hope it falls within the flow of the discussions today. Social Alpha is a multi-stage incubation cum investment platform for science and technology startups that address the most critical social, economic, and environmental challenges through the power of entrepreneurship and market-creating innovations. Since its inception in 2016, Social Alpha has supported 145 startups, and we've invested into some 41 of those. We support entrepreneurs through a nationwide network of innovation labs, venture incubators, accelerator programs, seed fund, and market access mechanisms. Our primary focus is science and technology-based innovations, which usually involve high business risk, but also have the potential to achieve non-linear scale and impact. So at Social Alpha, especially in clean tech, we've strived to create a spectrum of incubation engines and accelerator programs to support startups that include access to lab and product design facilities, infrastructure support, including test beds, mentorship programs, industry partnerships and connects, and opportunities to pilot test solutions on the ground. The support also includes business mentorship, which is extremely critical for early stage startups and entrepreneurs. We have run, the Social Alpha Energy Challenge to scout for relevant startups and incubators for 2 consecutive years, which attracted over 300 applications cumulatively. Our incubation architecture includes 2 incubators supported by the Government of India. For early stage incubation, there is the Atal Incubation Center supported by NITI Aayog. And Social Alpha has set up in 2018 the Clean Energy International Incubation Center, CEIIC, with joint support from Government of India and Tata Trust, led by Department of Biotechnology and the Biotechnology Industry Research Assistance Council, BIRAC. And Tata Power has played a crucial role of a partner and stakeholder in this initiative. The CEIIC has also been recognized as Indian government's initiative to demonstrate commitment towards mission innovation, the international flagship program of 23 countries and the European Union. In this, the leadership and the able guidance of Dr. Renu Swaroop and Dr. Sangeeta Kasture from Department of Biotechnology has been extremely critical and has been very, very pivotal to the growth of this incubator. So far, we've incubated 28 startups, including 6 international startups, where we are trying to provide a soft landing pad for international companies, and also invested into 4 of these startups. In terms of the coverage of solution space, we look at a range of technologies, and we realized that to make a difference to the climate scenario through clean energy, one needs to focus into the entire life cycle of energy, starting from production, generation, to distribution and delivery, to consumption and supply management, as well as storage and edge of grid technologies. Of course, there has to be a focus on affordability, accessibility, and user experience, without which it is extremely difficult to ensure that we are looking at energy access for all. We also focus on a range of use cases, starting from household, farm, industries, transport, building, infrastructure, utility, because each of these actors and each of these stakeholders have a role to play in our India's climate journey. This basically means that, at the incubator, but also at the country level, India's priorities when we talk about energy access and energy efficiency involve a range of, problem statements, from talking about clean cooking, which basically means making clean and efficient, affordable, and user-accepted cooking solutions available to all households and communities. Also efficient irrigation, decentralized cold storage solutions, agro-processing solutions for farmers, biomass to energy solutions, which are decentralized and on the ground. And also, solutions around productive application using renewable and decentralized energy. Then again, the grid infrastructure and the smart grid and the decentralized grid infrastructure, bringing in remote monitoring, automation capacities, diagnostic capabilities, second life use of batteries. Very important area is energy storage, starting from looking at a range of battery chemistries, but also looking at decentralized energy storage applications for microgrids and mini grid setup, and also looking at their second life use of batteries. The other critical area is that of thermal comfort or space conditioning, which essentially means both heating as well as cooling application. But when we talk about that, not just restricting ourselves to room air conditioners or the urban cooling and heating demand, but also looking at the underserved market, where maybe more affordable solutions and more efficient solutions can play a role. Electric vehicle is an important area. So not just in terms of the EV space itself, but also innovations in EV infrastructure space, involve a great deal of importance. And again, when we speak of electric vehicles, looking at four-wheelers as well as two-wheelers, three-wheelers, all kinds of modes of transport is important in the entire innovation consideration. And again, like we spoke about, there can be a range of regional, problem statements. There could be problem statements around desalination of drinking water. Renewable energy can play a role in a range of where technology can actually change not just the way the communities address those solutions, those problem gaps, but also in the way that we, look at the technology in a more renewable and climate-friendly way. Now, each of these problem statements or technology gaps that we spoke about definitely have implication on a range of sustainable development goals, starting from obviously the goal 7, which is affordable and clean energy access to all, and goal 13, which talks about climate action and looks at a global action plan around it. But also goals that look at reducing poverty, about gender equality, decent work and economic growth opportunities, innovation in industry and infrastructure, and reducing any kind of inequalities, not just gender, and as well as sustainable cities and communities as a whole. We must recognize, and I think it's too late for us to still second guess it, that climate change is here, and many of its long-term impacts have undeniably been set in motion already. There's and it's been showing that global average temperature has increased by more than 1% since the pre-industrial era, because the far-reaching consequences of which some of those evidences are already being experienced. There have been irreversible ecological shifts which have had cascading impact on human life, health, livelihoods, well-being, and on the environment around us. Obviously, the most vulnerable to the crisis are the ones that are anyway at the highest risk of any health or environmental catastrophe. And therefore, waking up to these threats is it's natural as well as man-made ecosystem changes is extremely important. And I think the world community has come together to recognize that the only way to do it is through what is called climate neutrality, or referred to as net zero scenario, where the aim is to not just reduce emissions, but also remove the already committed emissions into the environment by capturing and storing them into carbon sinks, or looking at emission levels of pre-industrial times. Now, this requires innovation. This requires newer technology to step in and give us solutions that will take us back to a very pre-industrial level emission scenario. India emits more than 3 gigatons of carbon dioxide equivalent per year, which is about 7% of world's GHG emissions. While we recognize that India's per capita emissions are almost the half of the global average, but there's a large population base, and which presents India, and the current that India is in, they present to India both an opportunity as well as a potential threat, to the global problem. And depending on how we make use of this point in time of the situation that we are in, and look at strategic interventions so that we can ride on the power of innovating technology and contribute more holistically to the global scenario, because this requires a systems change approach. So what do we require? We require optimization of existing processes where we make them more efficient and cleaner. We require replacement of whatever is inefficient and polluting, but we also require to create alternate processes and solutions that can bring about a complete paradigm shift. And therefore, the focus has to be, particularly for India, in carbon mitigation technologies, which is extremely crucial because they aim to reduce the factors that contribute to climate change, but also look at adaptation solutions, which are essentially supporting communities that are vulnerable, that are already experiencing the downside of changes that are already being manifested in the ecosystem because climate change is already happening. And therefore, at our, at Social Alpha and at the Clean Energy Incubator as well, we're looking at solutions that focus on both mitigation factors as well as adaptation to what is already being experienced. And therefore, in the country as well, the innovation ecosystem needs to look at and prioritize clean energy, climate resilient agriculture, waste to value, sustainable mobility and habitat, pollution and public health, sustainable consumption and lifestyle, water resources, as well as disaster risk management. Collectively, we've come up with, some of our 20 innovators were studied by RISE Sweden, and their collective carbon reduction potential has been estimated to be over 200 megatons by 2030, by the year 2030, based on their framework. But I think the opportunity as well as the crisis, both are huge. And therefore, the ecosystem needs to come together. There's a challenge in nurturing and supporting these innovations, particularly in their journey to commercialization. A recent report by International Energy Agency, the IEA, has shared that 35% of emission reduction potential globally lies in the innovation that is at the early stage. And nearly 50% is with the ones that haven't reached the market yet. This calls for a need to create an ecosystem that supports promising new innovations and handholds them to ensure they serve as many valleys of death in their journey from the lab to market. I think a collective action from all stakeholders, led by the government and all us, ecosystem builders for innovators, is needed to boost, innovation in clean energy, energy efficiency, energy access, and climate action as a whole. With that, I think I'll stop here.
Thank you so much, ma'am. Our next speaker is Shri Praveenjit Ji from Paradigm Environmental Strategies Private Limited. I'll just share the video.
Waste to energy through co-digestion of organic food waste and septage. Namaste, I am Praveenjit, Managing Director of Paradigm Environmental Strategies, an environmental consulting company focused on sustainable technologies. Our services include research planning, consulting, implementation, optimization, maintenance, environmental training, and environmental and social impact assessment. The focus areas are water, wastewater, solid waste, energy, and climate change. As you see here, we have operated along the length and breadth of this country, and our clients include people from 7 countries and 4 continents. We have over 300 plus projects in the last 14 years of our existence. Some of the projects we are proud of, we are part of the technical team which drafted the Municipal Solid Waste Management Manual 2016. We developed the decision-making tool, a software tool which is present on the Swachh Bharat Mission website. The waste-to-energy plant at Nasik, on which I'm going to talk about later. We have designed and developed the transport, storage and disposal facility for hazardous waste in Karnataka and currently doing work in Goa. Some of our projects have achieved recognition in the form of National Water Awards 2009 from the Honorable President of India and the first prize at the National Water Awards 2018. The significance of this project is gauged by that India is grappling with the twin challenges of untreated sewage and solid waste. As we all know, the standard ways of treating are composting or biomethanation of food waste or thermal treatment like incineration. The co-digestion model works on the principle that both the streams, that is the organic solid waste stream and the organic sludge from septic tanks connected to public toilets and houses, can be digested together in a single plant to generate methane, which can be fired in a gas generator to generate electricity. There have been research to prove that the synergistic effect of digestion of these two streams would help in generating additional gas due to the diverse microbes present in the substrates. So the first waste to energy project has been developed on a PPP model in Nasik Municipal Corporation. So the food waste from restaurants and the septage from public toilets and community toilets are brought to this facility where 20 tons of organic food waste and 10 tons of septage is digested together to generate almost 3,300 units of electricity every day. This project has been in operation since 2017. Eco Paradigm was involved as a technical consultant to the project along with Aqua Council of Germany. The project was supported by GIZ, German International Cooperation, with a financial support from BMZ or the Federal Ministry for Economic Cooperation and Development, Government of Germany, in a bilateral agreement with MOHUA, Government of India. So the summary of the project is it treats 20 tons of organic food waste and 10 tons of fecal sludge to generate 3,300 units of electricity daily. The project is located on a small land of 1.5 acres and has the ability to offset nearly 1,000 tons of carbon dioxide by way of avoided emissions. Most solid waste projects or the waste treatment projects are always affected by viability. Nearly 10 to 40% of a urban local body's cost is apportioned to solid waste management. So in this case, urban local body usually spends very conservatively about 3,000 rupees per ton to collect, transport, process and dispose solid waste. The NMC in this case gets back almost 1,000 rupees worth of electricity free of cost. So the net cost reduces by almost 33% to 2,000 rupees per ton as for the urban local body. Whereas from the PPP partner, the operator point of view, the investment is about 7.5 crores, and considering the capital recovery, the fuel, the salaries and the septage management cost, the actual cost per ton works to 2,200 rupees roughly. And considering that the tipping fee is around 3,000, there's a nice margin of 35%. Now, the figures might vary slightly, but you will get the order of profitability in this project. Now, what does this mean for the country? For the country, the untreated wastewater, which is almost 80%, would need about an installed capacity of about 33,000 million liter of STP capacity, which would occupy a certain patch of land of 8,000 hectares, and would also require electricity consumption to treat. That's about 6 million units, and in the process of treatment would generate about to 18,000 tons of carbon dioxide every day. Similarly, solid waste management also would have an equivalent stress on the land, the power, and the emissions. So the total emission environmental protection would cost about 9,000 hectares of land and consume about 6.67 million units, and with a net emission of 20,000 tons per day. On the contrary, if the Nasik waste-to-energy model is implemented across cities or small towns which are not having benefit of a sewer line, the land requirement would become about 20 to 25%, and the energy, instead of being consumed, it would generate almost 11 million units of electricity, which is a bonus. And the icing on the cake would be, instead of generating 20,000 tons to manage the anthropological pollution, we would be sinking almost 10,000 units tons of carbon equivalent per day, which is the icing on the cake. So this is the beauty of this project. So it ticks off all the right indicators like management of solid waste, liquid waste, generating power, and actually saving money while doing its bit to the climate change. So to summarize, we have to think out of the box, consider every problem as an opportunity, erase the artificial disciplinary construct, and take a leap of faith. That means we erase the usual boxes of civil engineering, environmental engineering, electrical, mechanical, biotech, and then merge it into a single project where each problem sort of nullifies and you get a best of all. So the model is think in terms of new eco paradigm. Thank you.
Thank you so much, sir. Next speaker of the day is Dr. E. Rajashekhar, sir, from Department of Architecture and Planning from IIT Roorkee.
Thank you for joining the session. I will be talking about energy performance benchmarks for buildings, challenges associated with it, and the ongoing initiatives in this aspect. My focus will be on residential sector. I would begin by acknowledging the initiatives by Bureau of Energy Efficiency and associated governmental and non-governmental agencies in setting up the energy performance benchmarks that we have today. There has been tremendous effort during the last decade to reach where we are today in this respect. When we talk about performance benchmarking of residential buildings, we have few key issues which need consideration to move ahead. For example, the dynamics of weather and its impact on energy use, and the impact of climate change, say within 40 to 60 years of a building's service life. While we critically address overall energy demand reduction, peak demand, which can go up to 3 times the mean demand, is still a persistent problem. Operational dynamics of the building, which puts user behavior in the forefront, is a factor adding diversity to the problem. Apart from this, the design choices in terms of efficiency compliance paths and cost-benefit trade-offs, which the designers and owners decide during the conception of the building, adds to the variability. I would draw your attention to the figure on your right, which I refer as dynamic performance when. As we see, when we study environment, building, and occupant independently, as we do today, we are deterministically regulating things. When they start interacting, for instance, occupants start interacting with the building, the usage pattern brings a wide diversity in energy footprint from what we can expect to happen. Similarly, occupant interacts with environment, environment interacts with building. So these interactions create the dynamism which we are really discussing in this session. As an example, a study we conducted in the warm, humid climate showed the energy consumption to be strongly related to the weather and weakly correlated to the income level and the building type of the occupants. For instance, the study covered higher middle income and high income group people residing in apartments with around 600 to 1500 square feet floor area. We covered over 600 such residential units. We found several middle income group households consuming energy on par with or higher than that of high-income group households. The variation our study showed was primarily from the cooling energy. When we project this pattern over the service life of the building, let us say 50 years of service life, we find a striking impact. The implication goes beyond just operational energy efficiency. If we consider the embodied to operational and energy ratio in the overall energy footprint of the building, let us say at the end of 50 years, it has a plus or minus 20% difference, which is quite a significant number. A recent field study in a hot, dry climate, in this case it was Ahmedabad, showed us that there can be 30% prediction uncertainties in annual cooling energy demand and 20% prediction uncertainties in peak cooling energy demand, even with a calibrated building energy model. This is attributed to three broad categories, which are weather, building physical attributes, and occupant behavior. We found that AC set point temperature is 27% sensitive and natural ventilation effectiveness is 15% sensitive, while operational duration of AC air conditioner is 20% sensitive to the total cooling energy. A similar difference was also found on the peak energy demand. This highlights the operational uncertainties or operational phase uncertainties as well as user behavior plus climate, occupant and building interactions and its potential impact on so-called the performance benchmark that we really set and commit for a building. Now, further to give a little peek on how the compliance is really happening, we trust the climate zoning is a pivotal to success of policy initiatives relating to any energy efficiency. We go with certain climate zones have to comply and have their buildings in certain way. Currently, we follow a 5-class climate zone, and this is the basis of our EPI benchmark provided by BEE and other agencies. What we did, we simulated a public housing scheme project at 50-kilometer grid resolution. We retained the design while we varied the weather data for over 1,400 locations across the country. We just took the same building, put it at different locations and simulated it. As we see, we find an interesting diversity which is of the order of around 10 to 15 times the magnitude. This is assuming the occupants are adapting to the climate and operating the building on adaptive set point. If this is not true, the diversities are going to be even higher. Realizing this diversity in building energy demand, we have developed a new 15-class climate zone classification based on high resolution weather data considered over 30-year period. This is purpose-built for building energy benchmarking as well as energy efficiency related studies and applications. We have also tested the robustness of this class for future climate scenarios and have phase validated it with buildings performance data. This work is supported by Department of Science and Technology and IISF as a part of India-US Building Energy Efficiency. Further, to enable designers to evaluate their designs to local context, we have synthesized localized weather data at a grid resolution of 25 kilometer by 25 kilometer for whole country as against 60 plus locations for which we have weather data available, like you see in the map to your right. This includes current as well as future weather data, which we are currently in the process of validating. We are also developing a thermal stress testing procedure that we call it as for buildings, which will help evaluate the mean as well as peak energy demand of a building and achieve performance efficiencies in both these contexts. The weather files that we produce are not just typical reference years as you would usually get, but they also include XRY, that is extreme reference year files, which is purpose built for peak energy demand assessments. To summarize, we need coordinated field studies and open access repositories of energy consumption data to facilitate such studies. We need to give due consideration for operational dynamics and transition to dynamic benchmarking from the static numbers that we have. Energy performance benchmark should also be set for peak energy demand rather than just the mean demand. Last but not the least, we need flexible procedures for designers to allow customizable compliance pathways for energy efficiency. Thank you.
So we are done with the speakers. Over to you, Tuli sir.
Okay. First of all, thank you, Dr. Priyanka and Dr. Bharti for conducting this webinar in a very good manner. It's been quite a learning, at least for me, for several of new things which have come up. And panelists have been exceedingly good in sharing their knowledge. For example, Dr. Damodharan talking about storage batteries of new type replacing lithium was very good. Grid stability by Dr. Padi was excellent. And then a talk on village level options for energy by Professor Vijay was great. Dr. Shams Yazdani talked about biotechnology, advanced biotechnology in biofuel. Thank you very much for this. Mr. Raje talked about innovations importance, which again is very important while Samita talked about social alpha participation in incubation and startup, which is indeed very important for innovation. Parvinjit talked how municipal solid waste and wastewater sewage can be treated, gave beautiful examples of whole this thing and how it can be discussed. And finally, just now, Professor Rajashekhar talked about energy efficiency in building environment. On the whole, very good. One takeaway from this, which several people talked, is that at village level, distributed anaerobic digestion can be a very good technology to start with. We are enriched with this. I hope the participants also. We have some questions, Dr. Priyanka, but we need some time to actually sort it out and forward it to the people who will actually reply to them. Thank you very much for the participants who have stayed on. We started a little late, and that's why there is a little overrun with this. I definitely liked the seminar very much. Thank you, panelists. Thank you so very much. Thanks, Priyanka.
Thank you. Thank you, Dr. Tuli. Thank you very much. And indeed, I would now like to request Dr. Sangeeta Kasturi from DBT to kindly propose the vote of thanks and have a concluding remark from her side. Dr.
Yeah,
Sangeeta.
thank you. And this is, thank you, Priyanka. This has been wonderful. I have learned, though I was on mute, but I have listened to all the presentations right from the, as Dr. Tuli has said, power balancing by smart grid, energy efficiency, then energy storage, then waste to energy. There were a lot of good presentations from academia, industry, and entrepreneurs. And I hope all these participants have learned from this, and there are good opportunities. A lot of schemes are available for public-private partnership, because many of these have already mentioned that there are a lot of entrepreneurial opportunities are there in clean energy sectors. And I heard from each of these speakers, we have learned a lot. And I hope all of you have also got enriched with this knowledge. And now, because of in the interest of time, I think we can't take the questions, but there are a lot of questions. If all these respective speakers, if they could address later or offline, they can be in touch with these speakers. They can provide their email IDs so that they can be in contact. So this is a good platform for networking, and I think we have been successful in that. And Priyanka has done very wonderful job. Thank you all speakers. I can read out these: Dr. Padi, Dr. Damodaran, Professor V.K. Vijay, Dr. Vanita Prasad, Dr. Shams, Professor Gaun Chaudhary, Amit Raje, Mr. Amit Raje, Ms. Smita Rakesh, Sri Pravinjit, and Raj Shekhar. All of you, thank you so much. And I look forward to having continued collaboration with you. And please participate in all other events. Tomorrow we have very good, exciting, and knowledgeable events. So look forward that you will be tuned with this all energy conclave. And thank you, all of you.
Thank you. Thank you, everyone.
Thank you, Dr. Turi, Dr. Sangeeta.
Thank you.
Thank you. Thank you.
Thank you, ma'am.
Thank you, Dr. Tripta Thakur.
Thank you.
Thank you, Amitji. Thank
Yes, all coordinators on behalf of Dr. Tripta and everyone has, in short notice, they all accepted. So thank you so much, Dr. Tripta, Dr. Priyanka, Dr. Vineet, and all your support.
Thank
Thank
you.
you.
Thank you.
Thank you.
Thank you. Thank you.
It was a wonderful session. Thank you.
Thank you, sir.
Thank you.
Thank you.